Okay. Luke Goodloomis's bio is in the meeting announcement and probably in the YouTube description of this video that you're watching sometime later. But I'll highlight a few of his interests because they're kind of fun. He enjoys playing clarinet and piano classical music, as well as jazz improvisation. He enjoys cooking, camping, accounting, which seems like kind of a left field thing, but good for you. Keep the books straight. Film scoring, surround sound remixing, and last but not least, yard work. And I'm looking forward to getting to know him more as we both serve on our committee. So without any further ado, please welcome Luke Goodloomis.
And thank you very much. To the topic of questions, if anything comes up that you don't want to forget, you could throw it in the chat. I think that would be okay, and that way we can look back later at the end if there's anything that wasn't covered. This is going to be a fire hose, a nuclear blast of information, a shotgun of topics. This is going to be a full survey of the installation of the upgraded audio system for the American Museum of Natural History's Hayden Planetarium. That audio system is spatial in nature. And so we are going to kick it off before I begin with a primer from JJ. I'll start sharing here, and then JJ's going to go through some stuff. This is also going to be a bit of a panel discussion, and I heard lots of delightful trigger words for me like ambisonics. So yes, if there's questions, experts in the room that can even, contribute or discuss or add that little extra seasoning, since we can cook on this topic, please chime in, right? This is a conversation. I think we have a lot of expertise here, and it's good to share all of that expertise and knowledge. So here's the agenda. Let's see. Are you seeing this agenda screen?
Yep.
Yeah. Yep.
Fantastic. And everybody else disappeared because that's what happens when I share. Let me just move that so I can see people who talk. Great. So we'll have a spatial audio primer. We're going to go through the history of the Hayden, a bit about the museum itself. That's going to be with Mr. Russ Baird. And we're going to talk about the existing system, or the previous system, and some of the projects, goals, problems, how we identified it, cataloging it all. Go into research, product evaluation. We'll get into the final design, and then take us through construction and commissioning, and then wrap up pretty quickly with some remixing and in space shows. I could talk for days on this, so I'm going to try and limit it. I'm going to target an hour and a half to 2 hours. It may run over that. So, yeah, we can get into it. With that being said, Mr. JJ.
Well, I hope that I'm actually visible. My iPad just spazzed on me. Can people hear me?
Yes.
Okay, I see yes.
See you. Yeah.
I don't see my face, but who needs that? Go to the next slide. I'm going to talk about basically hearing and how it relates to signal processing. And to put it very simply, first arrival of what's intended to be the direction is key. You really can't get past that. Cocktail 40 effect is really important. And if you want to be able to hear the message, you really don't want to have the effects imaged the same place as the message. In fact, you're better diffusing the effects than you are imaging them somewhere else. Because if you image the effects somewhere else, people are going to look up and look down and look around, and that's not going to be so useful. The other observation is here that domes are sort of the opposite of an ideal acoustic reproduction system. So you got to have absorption. You have to deal with the perforations, and you really need to make sure that you don't mess up those little perforations in the dome. So switch. Next. Thank you. So what I mean by diffusion, I mean, if you have a time-aligned balanced system, first off, you don't have that. I'm not going to try. But what you want to do is you want a kind of diffusion that does a different diffusion to every speaker. That will basically make that all around, and it will help you get a 6 to 8 dB, if you will, emphasis on whatever your main message is without having to actually run the gain up. It's not hard to do. I'm not going to get into the math. There's a lot of math and a lot of prime numbers and a lot of filter design involved, but it's entirely not hard to do. And if you have lots and lots and lots and lots of speakers and you're really worried about losing track of the message, then you take the effects out of the speakers that are nearest to the direction of the source. And then you drop your message into that hole. Next slide. Domes. Well, I'm going to let Luke talk about this. It makes time interesting, time in alignment interesting, even assuming you've dealt with all the reflections and stuff. What do you pick as a 0 point? Where do you figure that the prime listener is? Somehow, if you have the prime listener sitting in the projector, that's probably not useful. But you really want to do time alignment. You really want to have a good balanced system, because otherwise you're going to start attracting people into speakers and attracting people into overemphasized or underemphasized things that are going to distract the audience. And really, for this is not a question of exact, precise reproduction. It's a question of don't upset the listeners. Next slide. Okay, basically, how do you do this? Well, I would say what they call objective-oriented there, but basically you should have positioning of the message in a smart engine that lets you put it wherever you want, and it does all the other thinking for you. Otherwise, production is going to be a pain in the neck. You let the engine do the imaging, you put the image per the time delays to drop out to diffuse the effects and reverberation and stuff like that. And you use time. You absolutely use multi-channel panning. You don't do single channel panning. I can explain that more if people want to ask, but let's not derail the rest of this enormous fire hose of information. And finally, since you have circular seating, you can't do 7 channels. Fortunately, you can do 8 in the horizontal plane. The problem is you have to have 3 in front, and you have to have 2 on the side and 2 behind. But if you have people facing opposite directions, that turns into 8. Next slide, please. And for that, I'll pass it all over to Luke, because I think he's got a ton of stuff to say. So I'm now going to mute and be quiet.
Thanks, JJ. That was great. And we will definitely discuss most, if not all, of those topics. I think some of the timing delays, creating a what we ended up calling a sound canvas that is designed for proper spatialization. A lot of that will come in when Bob starts talking as well during kind of commissioning and tuning. So closer to the end, but it's coming. All right, here we go. So the history of the venue. Russ, do you wanna say some about maybe the museum itself? You can give an introduction, talk about the iterations of the Hayden Planetarium even before the renovation, which is what we see here, the new renovation that happened 1997. It was closed and then reopened in 1999. Yeah, give us a little bit of the insider information.
Sure. So the Hayden as it exists today is a far cry from what was a historical institution in New York City with plaster ceiling. The original Hayden was a very different animal from what we see in here today. Um, that being said, uh, I was initially very upset to hear that the Hayden was being demolished when it was, and I never thought I'd actually be involved in the current version of it because of that. However, uh, times change, and the need for a different technology, a plaster ceiling you cannot put speakers through, so you also can't do a lot of other things that we expect of a modern theater in that type of space. Uh, the only way to have improved the original Hayden was to demolish it and replace it with something new. Um, Luke's showing you a slide of the current building. The planetarium is the top half of that ball. The bottom half is another little smaller theater called the Big Bang Theater, which projects an image below your feet, which is another whole story. But the top half is a in the round, like the original Hayden was, seating arrangement. It seats approximately 400 in change, 425 seats. Um, our goal is to have it so that you could sit anywhere in that theater and get an enjoyable experience and not have to prefer uh, a certain area or a certain place to see the show. That adds an additional challenge because most domes that are constructed now uh, get around this issue by having what's called a uni-tilt setup, where the dome skin is actually tilted forward, more like an IMAX theater, and the audience is seated not in the round, but mostly facing a center channel. This makes things much simpler for setup and design, and also makes it easier for mixing because you can do a traditional 7-1 or 5-1 setup. So this Hayden that we're looking at today has none of those advantages. So we like to do things the hard way. So this theater requires a much larger sound system because we wanted to make it possible to spatialize things in a way that wouldn't be possible in a traditional arrangement. And also, the way the theater was designed, if you notice in one of the pictures Luke was showing you, it still has a Zeiss projector, although you won't see it. It actually comes out of the floor, that middle section there is a giant garage door opener, for lack of a better term, and the Zeiss ball will actually come up out of the floor, and you can still do traditional planetarium lectures. Of course, that's not what we do most of the time. We're showing a movie, um, which is usually about 25 minutes and change, usually curated by one of the physicists at the institution. The current show is chaired by Jackie Faraday, who's very involved with the Gaia data set. Um, we have had Neil Tyson do a show on dark matter, and the shows are generally well received. We try to steer away from anything cartoony or anything. We try to stick to as close to the real material as we can. Of course, it's a show, and it's going to have sound, and we do sound effects and music and all that. But just so you know the background, it's truly a labor of love. We use projectors that are very specific. They're Christie Eclipses currently, 6 of them blended together. This gives us an incredible contrast ratio that allows us to do true blacks. So when you come to this theater, you're going to see a show that has a large number of channels of audio, the purest blacks that we can get, so you can feel like you're really in space. It has a very primitive seat shaker system, which was installed as the caveman would do, but probably wouldn't be done anymore. But that's a story for another day. But the idea is to give you an experience as if you were on a spaceship and you're flying through the reality of space, as close as we can bring you. Do you want me to keep going on this part?
That was great.
Or you want, give you a little background.
Segue into this, and then I'll take it away. Go for it.
Great. So the background is when this theater was being built in the late 90s, there was a lot of questioning as to what would make a show. What would people want to see? Would they believe that a movie, a digital movie, could be as good or as exciting as a Zeiss Starball presentation, like we all remember from kids and our first experience in the planetarium? Could we do something with that an audience would believe and feel? So there was a lot of debate as to what that would be. And making a show, the very first show, was a challenge for those reasons. So, of course, we brought in some theater people. Batman and Robin, in fact, was the first group to take this on. And they're a theatrical group, so they went with theatrics. We had fog, the seat shakers, as I already mentioned, techno beam lighting to light up the star ball as it came up out of the ground. So a lot of theatrics, because they were worried and very concerned about, first of all, how do you make 3D rendering video that looks impressive, that is true to its subject matter? And then two, how do you mix such a thing? At the time, there's the Zeiss Starball and its lift position coming up out of the ground. How do you make this sound really good, and how do you mix it with the primitive tools that were available at the time? So that's where we started. Of course, we went to Meyer and we got the first gen of the distributable sellable speakers they had. They were CQ1s for the top channels, the Zenith channels, we called them. And the rest were all UPA 1Ps, which were excellent speakers for their times. And what we did is we arranged them in sort of a circular pattern. The CQ1s were the voice channel, the voice of God at the very top. So we called those the Zenith channel. And there was 3 of them. And they didn't cover every spot perfectly. They just can't. But they did a fairly good job. The big challenge, this is a map Luke's showing you of the speaker arrangement. Those 3, 1, 2, and 3 there are the Zenith channels. That's where the voice would come out. And then as we evolved the mix, the next ring, which we call the Sky ring, which are all CQ1s, that's channels 4 through 11, I believe, were primarily the music bed, but also some effects. And then the lower ring, also all UPA 1Ps, were the Horizon ring. And that's where most of the effects bed would live. And so how do you mix a thing like this? The very, very first generation of level control systems, the LD88s, was our first platform. And I remember Richard Bug from now of Meyer, but of LCS at the time, coming out and hand sawing all the fiber channel ports to get them to connect together because the units would flake out. And we had to mix them on in BIOS to a hard drive that had no file system. So you had to directly write the files to raw platters. Oh, the memories. I'm sure you're all laughing at this, but yeah, so that was our first gen system, was the LD88s and the speakers. Now, the speakers are difficult to replace. They were behind a screen. It was one of the very early Astrotech Planetarium perforated screens. Had a lot of seams, has a lot of metal up there to make this thing hold steady. And the whole thing is chain hung. So the entire structure, in order to have the maximal ability to put projectors wherever you might want, and that little cove area between the screen and the bottom lip of the theater. So the entire screen is hung on chains. And when you go up there and you can walk on the catwalks above, the entire thing sways a little bit, moves. Only when you're up there, not when it's being shown to the audience or anything like that. But it is truly I have to tell you, my first time up there was terrifying to go check on the CQ1s, and you look straight down from the zenith position, and there's nothing. See straight, you see right below your feet. So it's for a non-theater guy as I was at that point, it was a exhilarating and scary experience to check out the speakers up close and personal. But what Luke's showing you here, and this is one of the challenges that we'll be talking about later, is the amount of metal that's up there. Modern skins, modern domes, don't use as much structure. They're a little lighter. But at the time, the gauge of aluminum that was used for the very first dome skin was very prone to movement and flexing. So they had to build a very strong skin. We've since replaced the skin. Due to budget reasons, we kept the frame. So the Astrotech frame is now holding a Spitz nano seam screen, which is lovely. It has a lot less seams. When you have bright seams in the video, you're not as distracted by the seams running in the grooves in the actual material. The holes are microscopic, although you can see right through them, and especially in this picture, this is a great picture, Luke, because it shows you the theater lighting coming right through the skin. And Peter Holinsky, our mixer, our longtime mixer, and I had done some experiments early days in this process of shooting the speaker through the skin at various angles to try to figure out where what our range was. And I think Luke, you were present for some of that as well, and figure out what its limitations are, because the manufacturers will always tell you, oh, it's seamless, it's transparent, it's, of course you all are students of physics, I'm sure, and know that is impossible. So there are limitations. However, we did find that there was quite a bit of range and what you could do, and that worked to our advantage, as Luke will tell you in the next part.
Yeah. Thank you. So setting the stage, what we're doing is, for those not familiar with the newest design of the planetarium, to get you an idea of the physical limitations and constraints that we were bound by. And then we'll get into the system, because the logistics and the physical aspect of getting things in the dome, I think, is just as interesting as the sound system. And at one point, there was a crossover of kind of risks and problems to figure out, where we had figured out the sound system. We knew generally 90% it's going to be this, but how to actually install it, we didn't know if it was even possible. And ran into additional challenges that we'll get into, that just compounded that risk, leading to impossibility. Because the theater is the top half of this. It is suspended, like the sphere of the planetarium is suspended, and then inside of that, the screen and the whole screen structure is suspended. When we started the project, 2022, 2023. And at the beginning of the project, I came in and I spent, I think, 3.5 hours sitting in every seat of the planetarium, listening to all of the space shows that had been played, just one after another. And throughout that, I just went along every row, every seat, to try and get an idea of what it is we were going to do. It wasn't enough for me to say, well, let's upgrade it and give it the best sounding system that we can today. We can be a little more specific than that. We can have some targeted goals that we want to identify. And so throughout the listening experience, talking to the museum, getting their feedback about the space shows, talking with Peter Helinski, who has mixed 6 of the 7 space shows now. Oh, that being said, I do have to do a commercial. The newest space show just opened June 6th, 9 days ago. So the brand new system that we'll be discussing opened February 13th. I'll cut to the end a little bit because this is fun. Opened and give the planetarium a plug. Opened February 13th. It was 2 days ahead of schedule for this project, which again was amazing. And then remix of the show, and then mixing of the new space show, which just opened 9 days ago. So you'll be able to see the brand new space show on the brand new sound system. When we first started the project, we were figuring out, we're going to talk about documentation and existing documentation for a second, and then we'll jump back into kind of the problems that we needed to solve. They kind of go hand in hand, and you got to do one first. The existing documentation we had was these 3 drawings. And that's it. So we can't build off of that. Talking to manufacturers, they have to make predictions using their software. It has to be software that is able to locate things in 3D, right? We need some kind of a 3D model to be able to use throughout the project. And so one weekly meeting we had, looking at the options, found a company called Matterport. You may have heard of them. They do a lot of scanning of buildings, and you can kind of hop the Google Street View version of a building. Went online, amazingly enough. Tried to call them a couple times, didn't work. Went online to their portal and just started ordering a scan of the Hayden Planetarium. And the paragraphs that I wrote in the additional notes section were a couple of pages because it was just like a normal portal for like, yeah, just type in my address and they'll show up at my place of work or my house because it's big in real estate. This is a planetarium. This is for the American Museum of Natural History. You need to contact us. This needs to happen by next Tuesday. It was Thursday at the time. Within a couple hours, they had called and we got it set up. A gentleman came in and spent about 5 hours scanning both the inside of the dome and the outside or above the dome. And that is a lot of these images. You know, there he is right there. But a lot of these images are from that scan. So this is the old system we're seeing with all of this rigging. And they also provided a 3D point map that we could turn into Revit file, other 3D files, give to the manufacturer. So now they have a tool, because we will eventually get to the point where we know the problems, we know what we're trying to solve, and then we need to have that conversation with the manufacturers. So then they would have that tool to be able to make informed decisions. Off of that, here, since we're talking about the getting a lay of the land. So it is a non-tilt dome. It's the 360 degrees, seating in the round. Space shows are produced for that in terms of image, where image happens, where the center of image is, and consequently audio following video with effects. That also means video has to happen all around. So it is a 360-degree experience, a hemispherical experience. Here's a fun section. There is a small grade to the seating. This is a nice section that shows the various ribs. We've got some of the loudspeakers in a bit darker. This is all from that scan. We're actually quite impressed with the scan. They got things like the fire extinguishers, which was in the model because it was scanned. Here we go. Here's a distance, 69 feet 1/2 inches from at least where this section is taken to this soffit. Going through some of this duct we see up here is all mechanical duct, and this outside, so we have the screen, right, with all of these ribs with this structure. We have the catwalks that we'll see in some photographs to reference. We have these projectors in the tech gallery that is only about 6 feet, 6 to 8 feet, 4 feet in some locations. Not a lot of space to try and remove a subcluster and 3 speakers from the top of the dome because they have to come down the side. And additionally, potentially more difficult to get even larger subwoofers up to the top. That's pretty fun. There's another section. Here's a great section. Keep this in mind. We're going to look at this infamous soffit here is going to come into play in a little bit. Here's another. Here you go, Luke. Here's another image of the soffit that we'll talk about. And then here's a fun isometric view, 3D of the dome. So we can see the mechanical ducting that runs along the outside. There's electrical ducting. There's lots of ribbing, lots of structure hanging from the ceiling, and these tie points. So this is the physical environment that is a constraint that cannot change, right? So that's baseline. Approaching the project, regardless of what we want to do with the sound and grand visions we had, there are physical constraints and budgetary constraints, but physical constraints that limited what was possible. Here's another dollhouse view. That's kind of nice. We can see the curvature of the screen. We can see the locations of some of these existing loudspeakers. Again, this was the previous system. This is the scan that happened, I think it was December of 23, somewhere around there. We even get this section. Here's the little doorway. I have some photos of the ladder to get into the tech gallery. That's what that is back there. Great. And then we looked at this a little bit. So the existing system, it's a 23.1. I may have you, Russ, chime in a bit to talk about why that happened and how that happened, but a little bit about the 23.1. We looked at those loudspeakers, and now we can see kind of how they fit. So this is a top-down view of just the skin of the screen from as if you were kind of looking down with all of the loudspeakers in place as well. So a plan view of the outside and loudspeakers, and that's side by side to I think this is an export of the old Meyer space map file. You can chime in and correct me if that's not right. Please correct me. And we can
Luke,
look.
did you say what the subwoofers were? You said the mains were CQs and also UPA powered.
I think they were they 900s? Were the old ones 900s? That doesn't sound right.
I think they had 900s in those days.
I don't think they did either. Yeah, Bob.
Well, they were bag ends initially, and they were removed quickly.
Back in the day.
When we did the Sonic Vision, the music video show, Peter recommended we add larger subs. So I think we did 2 dual 18s, which in 2003 would have been Meyer
Whatever these
PSWs, maybe.
If it's the 18s, those would be 700s or 600s.
Yeah. Probably 700s, I'm guessing.
Yeah.
The PSWs had 15s.
See if I get another. I think I have another angle. I don't know if that's even
That's the first generation power supply, power amp. So that are you sure they're 18s? Because those kind of look like PSW2s.
You're right. They're PSW2s.
Okay.
PSW2s, Dan. W-2. Go to the PSW6.
Weren't those the cardioids?
Yes, PSW6 was had 15s on the back and 18s on the front.
Yeah.
And this is not that.
Slice of subwoofer.
Yeah, these aren't those.
These are definitely not those. And there's not that many people sitting behind them, so not a lot of benefit to that cardio sound.
Only every now and then.
Just the mice.
Just the mice. I was trying to find a cut sheet on the archives. I'm not finding it. Okay, we will continue. Great question. If the other questions, any questions so far? I'll pause here since we're talking about the venue.
I have a question about that picture on the left.
Yes, sir.
We're underneath the dome by a bunch,
Yeah.
right?
Yes.
The sphere.
Yeah.
And is this the main entry to it?
This is not. This is kind of 2 levels below. The main well, depends what you call
This is the whole of the universe is the lowest level, and that is got a lot of it's a Ralph Applebaum designed display area, and there's like a wall for galaxy, a wall for planets, a wall. So it's like a gallery about space things that were discovered. And it's also a space where that can be used for parties and stuff like that. There's a Samsung video LED wall down there, et cetera, et cetera. So it's a gallery space. There's the meteorite right there in the middle. And that's a fun thing to the opening party, January 1st, 2000 was down there for this for the opening of this the planetarium.
And is there wheelchair access to the viewing area itself?
So even though there's a staircase on the right there, there's actually a handicap ramp on the left side. Although you can't see it in this picture behind the LED video scroll. Yeah. And then what you're seeing above that spiral there is a ramp that comes out of the Big Bang Theater, and it takes you down this. It's called the scales of the universe, and it takes you exponentially through all the different sizes of things down to the atom. So from the largest structures down to the smallest as you go down the ramp. And
every meter is a power of 10 or something like that.
I believe so.
Yeah.
And supposedly the sphere itself is supposed to represent the sun in scale. And then if you can see in the top left corner, you can see Saturn hanging there. Those are all to scale. So if the sun and the planets were that close together, that's how they would look size-wise.
Cool.
Yeah.
And that spiral walkway, that's handicapped accessible?
Yes, it is.
Cool. Okay, thank you.
Yeah, just about everything is in the Hayden space.
Yeah.
Except the catwalks.
Styles has his hand up, I think.
Oh.
I do, if I may. First, I'll just say that I visited the place in 2004 and was when I was in New York and was greatly impressed. I mean, I was pretty impressed with the effectiveness of the sound system. I was greatly impressed just that somebody had figured out to do that. My question is about an earlier slide when you were talking about the original 1999 sound system, and there was a little reference there to the back row problem and the narration problem. Were you going to talk about those at some point?
Yes, nice. That's a perfect segue, actually.
Oh, how cool.
You're part of the cast now. Yeah, that's great. We're gonna jump into now. What are we doing with this sound system in a twice suspended sphere that has only 6 feet of room on the backside of the screen to do anything? Um, so what are the goals? Some of them were take advantage of modern audio equipment, right? Technology has changed, driver technology has changed. We're going to get better uniformity. We're going to get better clarity. We knew that. Can we do better than that, though? Well, let's figure out how to make a better spatial canvas. So we played with this idea of what is the best spatial canvas to create, and thinking about it as a painter that approaches a gessoed canvas and they're ready to do their thing. They don't have to gesso it, they don't have to figure it out. But what is this surface? What is this environment that is going to be able to reproduce spatial audio or produce spatial audio the best? So that's accuracy. That's also helping to mix. We'll get into part of this thing of accuracy in a little bit, and to assist with mixing. Peter, after mixing in that room for 20 years, had some ideas about how to make it better. And then we also had this what was identified as a back row problem and a narration problem. Some of the other goals. There we go. We can go back to this. This is a little better. The existing shows play back on 24 tracks. The previous system was a 23.1. The dot one were those two PSW2s, if I have that right, at the top. And the rest were those 23 speakers we saw on a couple of those images. There's also events that happen in the space quite regularly. About every other week, something happens in the space. It's rented out and used for events. So we need it to be flexible, multiple audio formats that need to be played back, flexibility of I/O depending on what type of event that that they want to have. It was identified anywhere from the Starry Nights, one person with a microphone talking, to a quartet, to a rock and roll venue, to someone wanting to take over all of the speakers one to one and play some wavefield synthesis or ambisonics projects that they want to do. There were also some seat and floor shakers that had just become non-functional over the years, and through other kind of architectural upgrades, seat upgrades, many of them weren't working. And then there were some acoustics challenges, some opportunities for improvement that had to do with the soffit and that had to do with the projectors. The projectors are quite loud. They really make the rockets sound like the rockets are taking off in there. So we have electroacoustic system goals. We want to achieve uniform coverage. Those ribs we saw, yeah, they get in the way of audio. And with the older style of speakers, the ribs and the structure of the screen introduced unwanted acoustic effects to them. Some of that culminating in a really variable listening experience from seat to seat. It would vary, plus or minus 6 dB, depending on frequencies. Some of them plus or minus 10 dB as the frequencies get higher, just because it's going through the screen and then bouncing off of unwanted things, or being affected by those ribs. And we wanted to provide a more precise and accurate sound canvas. So we needed to increase the quantity of speakers and distribute them uniformly. That was the initial goal. The back row problem. The back row was not the best experience it could have been. And we wanted to give the back 2 rows really more life. The narration was from those 3 loudspeakers up at the top. Here, I'll go find them again. And there we go. So these 3 loudspeakers, there's a few challenges to just this narration problem. One of them is that they are pointing through the world's worst design waveguide, right? These are 6-inch aluminum mini I-beams, essentially. Like it wasn't great. Additionally, the loudspeakers were cross-firing to the other side of the audience. If I have a minute, I can use this one. We can do this in real time here. So this loudspeaker was going to this audience. This loudspeaker was pointing to this audience, and then the third, which we don't see, was pointing to the third audience section. So we have these 3 audience sections, each with a loudspeaker opposite and firing in that direction. Makes sense. You point the horn more perpendicular at the audience. But to JJ's point, one of his points at the beginning is time arrivals, right? The first time arrival wins. Whatever you hear first wins. And so what happens is, let's see, 8'9". Are you still? We can do this. Fantastic. So looking at time arrival is distance. If you are a high frequency, then you're gonna be okay. You're 47 feet, 48 feet coming out of this loudspeaker. And if you're sitting on this side, pretty much the same, 45 feet, 46 to center, right? We'll just go center. We'll make it easy. However, if you're a low frequency, you're coming out of this box. You don't care where I'm pointed. And that's 42 milliseconds as opposed to 45 milliseconds. It can get even worse if we look at one of these seats in the back, where what happens is you'll hear the mids and lows from this closer box first before you hear the high frequencies, the sibilants, the intelligibility frequencies from the loudspeaker opposite you. And it ended up just muddying the sound. It created a less than desirable, less than optimal intelligible sound because you're getting 2 different time arrivals of the same content. They are all mono. They're all receiving the same content.
And that's going to hit right in the middle of the third formant.
Yes. Depending on where the seats are, I played this game for weeks, kind of getting an idea of some of these numbers. And we saw time arrival differences of up to 18 milliseconds in some locations, depending on kind of where they sit on the edges or in between or quite opposites. So that was a challenge. So we looked at that and said, okay, well, can we flip the speaker around? Not ideal, maybe, because there's a screen. It's a perforated screen. There's holes in it, but the holes aren't that big, and the sound still has to get through them. Or can we find a loudspeaker that is so directional that the low frequencies, mids, lows, still go where they are aimed and do not go where the loudspeaker is not aimed in a form factor that can still be installed above the screen and at a cost that is affordable by a museum. We'll get into that. That's a cliffhanger. We'll call that one. So that is part of the narration problem. Between that waveguide and the time arrivals, we knew there was a challenge there. And so there's the audio goals, the what now? So how do we play 24 wave files intended to be played one-to-one on 24 loudspeakers on a new system with different quantity of loudspeakers in different locations? Russ, do you want to give a little insight and explain what that means? Because I just said that like I knew what I was talking about. But what was the playback? Because it's straightforward, but it does take thinking about it twice in order to.
Yeah, I mean, it was a lofty goal, which we still haven't really achieved. But the concept was, oh, gee, we've got this huge catalog of shows. We're going to replace the whole system. We're going to change where speakers are located. How are we going to play the old shows back on request and still have them sound as good as they did with the original system? And that's still a tricky question. The simple answer is we remix the shows, but the other answer is that there are tools out there to, remap, let's just say, some of the sound, which we're still experimenting with at this point. But yeah.
So what we're talking about is this was the old sound system. Here's our 23. We don't see the subs, but they're stacked here in the middle. We didn't have a design at this point. This was just identifying goals. This was part of the project charter, figuring out what needed to happen. We knew that whatever the new sound system looked like, which we didn't want it to look like this because we knew there were deficiencies in this. Whatever it looked like, whatever the positions were, still had to play back the old shows. The old shows, the archive of the old shows, is a 24-track player that plays a direct analog out from the player to the loudspeaker, and printed into that track are the filters and delay settings of the loudspeaker. The audio did not play through a DSP, have filters and delays through a DSP actively, and from output of that DSP, then go to the speakers. There were too many risks and too many failures, potentially, of that model. So what was the most rock solid, redundant, because you could have two of them playing simultaneously, was a playback machine playing a one-to-one correspondence of audio. Well, that makes sense. We do that all the time, right? 715. Okay, no problem. And the panning is all in those printed tracks. So if Jupiter goes across the sky and a giant sound goes across the sky from 21 to 10 and then up to 3 and 2 and down to 9 and 15, in those printed tracks, that sound would come and then go. Pretty standard. What isn't standard is those filters and delays were also in that printed track. And that's the sound we have. So that's interesting. What we need is, well, the answer is look in the cereal box, and we'll get to that one too. Because we're still talking about goals. We're not talking about solutions. This is all just what are the challenges, right? What do we got to do? So events, modern and flexible. The previous system for events was mono only. It was too difficult, too challenging to try and fit a remix of stereo, quad, 5.1 for that system for an event. And so the two options were, you got mono, and you can have a mono coming out of all 23.1 with the dot one. There's a crossover in there. Or you can have all of them individually, and you can control it, but now that's on the events to control all of them. So we knew that the new system must be able to play mono, but left and right, LCR, 5.1, 7.1, and ambisonics. And the 5.1 and 7.1 is you say, well, how's that, again, back to Jade, how is that going to work if it's 360 and are you going to be facing the rear of the room for 7.1 content? That's a great question. I'm glad you asked. The answer is no, we won't do that. What we'll do is if a movie came in, a rectangular piece of video would be projected on this above or on the screen above this smallest section of audience. And so it would be kind of a 180, and maybe you'll rope off some of those so that it really is a directional image now. And now that we have a direction for the image, a specific front and rear, then that 5.1 and 7.1 can be mapped very easily. We can see that when we get to the end. There are some wireless microphones we've got to hit in there, some feedback eliminators, because now we're pointing at least 23 speakers at a microphone and gain before feedback. That's fantastic. There's no problems at all. BYOD, if someone has any device really that plays audio, how can we help them out? Give them still the ability to do a one-to-one takeover of all the speakers, and they needed multiple front of house locations. There is this location where the booth is right here. So this is the pit, typical front of house or normal front of house. But for certain events, they also wanted to be able to have a mixing console out here and either plug in locally or run some cables. Let's see. How are we doing here? And Tactile and Haptics wanted to fix the seat shakers and the floor shakers. Here's an image showing the wiring of the original seat shakers. These are the seat shakers. And some acoustics. So that soffit. So that back row problem, that narration problem, was multiplied, compounded by this soffit and this back wall and this rectangle. This is painted plaster that is circular and reflects and was causing all sorts of acoustic interactions with the loudspeakers behind the screens that were facing the audience, throwing to the audience. It was still picking up. So this whole soffit that we see, these little yellow lights, this is all a black painted, acoustically reflective plaster surface. Directly under that is 1/4-inch small pile carpet attached to the wall. And these rectangles once housed loudspeakers to try and serve as a rear fill solution, but were removed. You can take guesses why, but weren't filled in. So these are acoustic ports for that very loud projector that is just feet away. So the projector NC of the project. Luke, do you remember what the NC of the projector is? I want to say it was in the mid 60s.
Yeah, I'll pull it up and look.
Okay. Luke did some measurements there one night after everyone left. Yeah, so loud projectors coming through these portals. We have reflective sound bouncing off this soffit. We have small pile carpet kind of sucking up all that high frequency, the stuff that kind of, gives it a little sparkle. And we have narration with 2 different time arrivals, with the farthest high frequency time arrival signal going through the world's worst design waveguide. We had our work cut out for us. For sure. Any questions so far?
That's an ambitious list.
Yes. Yeah. Let's see. Here we go. Floor shakers. Yeah. Back to the soffit. Yeah. And here we go. Here's a nice image of that back row.
I have a question about these circles on the carpet. Is this like Google Maps where you click on that and something?
Yes, yeah. So these are screenshots before the Matterport portal closed and the account closed. I was able to go in and take a bunch of screenshots. But each one of those circles was a location where you could stand and kind of look around in any view. So yeah,
Cool.
that's exactly what they are. Yeah. Here we go. So here's a back of house as the entry. This is the doorway up to the catwalk. Here we are up to the catwalk. And now we'll get into some behind the scenes interesting locations. Here's a large projector. Here's some of the rigging points. We've seen a little bit of this. This is, existing sound system. So here's an interesting aspect. The entire dome, the entire screen that is attached down here, we can see this cable right here, this turnbuckle with a chain is attached to one of these up above. So it's fully suspended, as is the catwalk is fully suspended. In some locations, quite a spider web of cables and chains, very low clearances. We've got to get 23.1 speakers out of this place. We need to get, we didn't know how many, but more than that, at least 24.1 back into the space. And so what was, so the speaker placement strategy, we knew we wanted horizontal rings. We had the horizon. We had dialogue up at the top. We knew that still made sense. Sky, we called them sky layers, the horizon, the sky, and the zenith. There were tuning and delay considerations. And so how do we approach that? And so one thing, now I'm going to do a plug for AES. So one thing I did was go to the AES portal and I typed in spatial audio. And then I downloaded every article published from AES about spatial audio, including lovelies like ambisonic loudspeaker arrays. Yes, please. That one's very nice. Investigations on perceptual phenomena of the precedence effect using a Bessel sequence. Yes, very nice. And we knew that this wasn't going to give the answers, but it would help inform us of what the right questions were to ask. And so reading, I think there were, 75 of them or something like that. After reading through all of those, we had a pretty good idea of what we needed to do. Let me just close that one.
If you've got a second, Luke
Yes, sir.
Lassiter posted a grid or a graph of audio levels at different frequencies. Do you want to address that?
Was that in the chat?
Yes.
Let me see here. Boom.
Or Luke Lassiter address it?
And let me just preface this by explaining that the projectors were prototypes. So these are a Christie, what becomes the Christie Eclipse, and also the Dolby Vision projector that's used for Dolby Cinema. But these were early designs. They're serial numbers 1 through 6 of something that we were trying to recreate what we had with the original projection system, which were 12-inch CRT barcodes that were modified for high gain. Unfortunately, the high gain part meant that the tubes only lasted 18 months. That had to be replaced through the front of the screen, right below the front of the screen. So it was really, really expensive and difficult to maintain the color balance. So we had interim systems that were DLP, which give a nice image, but had a grayish background, which is horrible for space, as you can imagine. So these are projectors that were designed one-offs, essentially. The current design will make less noise, but they're much larger. So this was a compromise. So these were a smaller footprint than what they currently sell as the Eclipse. But unfortunately, that meant that the cooling system is they're cooled by ethylene glycol, I believe, or polyethylene glycol. So there's a pump cooling the laser diodes, and it's also a pump cooling the DLP panels, which are double modulated in the projector. So there's a lot of stuff that needs to be maintained at a fairly low temperature, and that's where the noise is being generated from.
Yeah, and tight tolerances. Yeah, and there's 6 of them. So going back to, yeah, thank you for that, Russ. That is super helpful. Let me see. I think I have an image.
But in fairness to the projector manufacturer, volume levels of 48 to 51 dB are hardly rocket takeoff levels.
Yeah, those are individual
Frequencies.
Let's see, the LEQ ends up a bit, I think, higher than that.
Well, it's at one projector location. You got 6 of them.
Yeah, that was
Can I bust in for a minute?
Sure.
Part of the problem is that the noise is broadband. And so even though the total level isn't very high, the noise is high over the high end of speech and effects, and it's going to mask crap out of things. So it's not, this is a case where the total level is not the interesting question, but the level in the spectrum per the level, per frequency in the spectrum versus the level per frequency in the source. And that makes this noise really problematic.
Yeah.
And presumably the background noise absent the projectors is pretty low in this space. Is
Yeah.
that true?
Yeah.
That's true.
Yeah. Mechanical's pretty low.
It's a cinema projector. It's designed to be in a booth. Unfortunately, no such space existed in the theater for that. So there you go.
Where the projector, even though there was the port that you showed us where the speaker used to be, was the sound of the projector going up into the space behind the fabric and coming down?
Say that one more time, please.
So the projectors are on the other side of the fabric from the seats.
Yes.
And there's nothing holding it in.
That's correct. Yeah, they are in the same acoustic space.
Yeah,
as everyone else.
Okay, that's making more sense. It's not just leaking through that port where the speaker used to be. It's everywhere.
Yeah, it's everywhere.
Thank you.
And they're projectors that are designed to be put in a projection booth, right? They were never intended to be put in the acoustic space of the venue that's watching them. And there's a projector, and then there's the rack as well. The laser engine is actually in a rack, and there's a 1.5-inch fiber connection from the rack, from the laser light engine to the projector head. And it's, and so there's fans in both of those.
The shipping model that they sell, the lasers are contained within the projector. So these are prototypes, like I was saying. So that they were built on an older technology, and then they've got a rack of 3 laser RGB units that essentially have a refrigerator bolted to each one of them to keep the diodes cool. And then there's a long fiber optic umbilical that brings the light into the projector itself. And then the projector is got 2 DLP panels, one for color and one just for black level, and that's the double modulation system. So it's actually got to cool 2 DLPs per projector. So there's a lot of stuff to cool. And we didn't know anything about the noise level until they arrived. So because they were prototypes. So of course,
models 1 through 6.
Yeah.
Serial numbers 1 through 6.
Got installed. We're like, gee, these things are kind of loud, Larry. That's Larry, who's the director of engineering for Christie. And he's like, well, they were designed for 50,000 lumens, and we're only using about 3,000, but you get the idea.
Yeah, a whole other masterclass on the projection system. So we've identified the problems. We know where things need to go in general. We know constraints, right? We know where they can't go. They can't go through a wall. So now it was time for the talk. we reached out to manufacturers armed with the clear identifiable goals that we had, each of those things, as well as some of the kind of core knowledge base about spatial audio and experience. We weren't going to try and assert our technical superiority and approach manufacturers with a design. We wanted to flip that. We wanted to say, hey, manufacturers, you guys are experts in your field and for your boxes, and you know exactly how they respond. You are familiar with whatever the three-dimensional imaging, not imaging, rendering software you work with. Here is everything we know and want to achieve with this project. So we created an RFI, request for information. It was a 23-page document I generated that was very detailed version of those previous slides of kind of the problems, challenges, constraints, physical constraints, history, a little bit to try and give context where it made sense. And we went to these manufacturers. We went to Meyer, Acoustics, Holoplot, talk about them, Harman, JBL, and Martin. And we wanted to find out what is the best system. We provided them that fantastic existing documentation, those 3 sheets from the original system, but we also provided the model and those Revit file, the 3D scan that we had from not Holoplot, Matterport, they had as well. So they knew the seats, they knew the existing arrangement of loudspeakers, and we really said, give us your best. This is what we have. Here's what we don't like about it. What solution do you offer? And that was about 4 months of discussions with the manufacturers. Every couple of weeks, we would meet, reiterate. Meyer, Acoustics, Harman, Martin, they were all great to work with. They were actually like really fun. We had fantastic conversations, and you know, some of the conversations where because part of the need back from them, one of the requests was heat maps. Okay, you're going to give us a system design. Now let's prove your system design can work. At least take the first step. Let's simulate it. And talking about this kind of things, these kind of specifications, requirements, the conversation of the blank canvas and spatial precision also came up. Is there a heat map that exists where we flip the capabilities of a spatialized spatial audio system where you would probably have to have, you know, pick one seat in the audience, a sweet spot, a reference location. And from that reference location, can you heat map the dome and show us what kind of resolution we will be able to get out of your spatial engine for said octave band? And that kind of broke people's brains because that doesn't exist and is very difficult to do. Some may argue almost impossible to do if that is also supposed to translate into an audience area larger than a single seat. All of the ambisonics, we'll say LOA, lower order ambisonics problems. We'll talk about that in a minute as well. So we went to the manufacturers. We asked for coverage, uniformity, frequency response, give us the best sound canvas, give us your options for spatial engines, which all of these manufacturers have. Meyer has Space Map, Acoustics has Elisa, Holoplot has Space Map, Harman has Spat Revolution, and Martin has Timax. Yes, Timax. So each of them have spatial engines that can fly sounds around. We also asked, hey, if we've got those 23.1 tracks, how do we play those back on your system? And so through conversations, right? Modern loudspeakers provide pattern control, flatter frequency response, better clarity. We wanted to increase. Another part of the conversation was, we seem like we know we need more speakers, but how many is the best quantity of many? And another question that came up is in the spatial audio processing side, if we're doing VBAP, DBAP, WFS, wave field synthesis, ambisonics, do we want columns or do we want triangles? And are they interchangeable depending on what spatial engine we are using? Because someone coming in, right, for an event may want to take over that one-to-one. They may want to be able to play ambisonics. So what is that best arrangement? Again, we had ideas, but we weren't going to provide all the answers. We wanted that better spatial canvas. We read more papers. And yeah, here we go. So we discussed, VBAP versus higher order ambisonics, DBAP wave field synthesis, or some other kind of homebrew. Is there a smaller new tech out there? The museum needs tech to work. It needs to work well. It needs to be solid, but it can be bleeding edge. It can be the first of its kind. It can be the first 6 of their kind, like the projectors. They're not afraid of that. The museum has very, very capable tech personnel to be kind of the first and second and third and fourth line of defense if something goes wrong or to get something back working. They are probably one of the most technical end users that I've ever met. So looking at this electroacoustic, there was that lack of industry performance metrics, right? That heat map of the dome from that single listening point, that single audience point. Where's that heat map of the dome that shows what the spatial capabilities are in a performance type of metric, right? Can we put some numbers? Can we put some science? So one of the problems, the back rows solution. So now we're talking about solutions. How you doing, Bob? It's getting late. We'll get to you soon. Are you okay? I've just got to check in. He may have stepped away. I think your time's coming up soon, buddy.
I'm still alive.
Okay, good. Okay. So here we are. You aren't in this image, Bob. I think you are at the top of the dome aiming a speaker during this one. But here's Russ, and here's Peter, and here's more of the museum staff, part of the Rose Center of Engineering staff. And this is our shootout. So the back row problem, how do we solve it? Well, we need backfills. Okay, so we narrowed it down to Meyer MM4s and some Anakondas. So this is K-array. They're flexible loudspeaker assembly that is comprised of, I think they're between 1 and 1.5. I don't remember the exact specifications. So this is a shootout. Let's see if it works. Let's not rely on, numbers or even renderings. Let's actually physical set them up. Let's take a listen. Let's do some measurements. We've got measurement microphones. There were a couple others added once we moved, so that we can be confident that this solution is going to work. And the narration was still a problem. We weren't sure exactly how to solve it. We'll talk a minute right now about hollow plot, but we also needed to test in situ. So during that same listening test of the back row, Bob was up helping aim and re-aim and remove and move a loudspeaker to try and find that sweet spot that it would work. Now, the hollow plot, who many of you, all of you, if you know, went into Sphere, wave field synthesis, and some other aspects of it. Their claim to fame is super directionality arrays, loudspeaker arrays. And that's why we were talking to them. hey, let's get that super directional. If we have to crossfire, the most directional loudspeaker in existence that will fit above that dome is this holoplot. So we talked to them. We went and listened to them multiple times. We had them do their renderings. And at the end of the day, for those lower frequencies that we're getting out of those original box, they were still getting out of the holoplots. It wasn't directional enough in those lower frequencies. So, the final selection, may I now introduce to the floor the illustrious, the man, the myth, the legend, who needs no introduction, but I'll give him an introduction anyways. The one, the only, the OG 606, Mr. Bob McCarthy. So Meyer came to the forefront. Their design they provided, they actually answered all the questions that we asked. They were the only ones that actually answered the questions. They were able to be creative. They added more speakers in different locations. They took each of those problems and provided an option for solving those problems. And Bob was, you know, a key, if not the key. I don't know, because I don't know behind the scenes. So I'll just say you did it all. We can do that. Anyways, take it away. What was that process like? What was kind of the thought process? What were the conversations that you had with Peter? Because I know you guys talked about that a lot. Just run us through kind of that design. How did that design really show up?
Well, of course, I talked to Peter, and I've been in the space and supported actually some concerts in the space, believe it or not. That's when I first met Russ. We did Mickey Hart doing a concert while his probes were on his brain, and they were scanning his brain and watching his brain work as the music played. And it's a sciencey place. It's really is Nerdville. So, but the bottom line is that I've been working on a lot of space map systems, and space map systems, when you fully develop them, to my mind, what you're creating is a planetarium out of a room, even out of a rectangular space or a whatever space. And so when I got a chance to design a planetarium space map system in a real planetarium, it was like, well, hello. The physical, for once in my life, the physical things were all in the right places. The shape of the room is exactly where I want to put the speakers. And so the basic approach that you have is that you want to be able to move things in your horizontal orientation to your brain, and you move them in your vertical orientation. You're mapping the sky, so you want to get speakers all over essentially where the stars are. And the approach that we wanted to take was, I looked at the current situation, and I felt that it needed another vertical ring. And that would be the key to making it so that it moved more gradually up into the dome. And the other thing to solve was the what they call a point destination array, which was placed at the top. That's this configuration that you described of the cross-firing speakers. It's not really a point source, because the virtual point of origin is ahead of the speakers. That's why I call it a point destination. And a point destination has all sorts of problems. Especially once it gets spread out, it has problems that is similar to what you described. Essentially, is just there's really no way to keep things going mutually in the right direction. So by adding another ring, that meant we could solve a couple of things. One, there was a fixation on having a speaker at the absolute top, like even though it was facing right into a structural piece of steel, a disc of steel that made it impossible for the sound to get down. But it's like you want to get the sound image to go high. Yeah, that thing. So my feeling was that we could get the dialogue up there and get the speakers turned around and make them into a point source and get the next level up high enough to where it satisfied the need for vertical without having to depend on that speaker at the very center to do much work. And once you've got your brain leaning way high up in the sky, your vertical resolution is not as strong as your horizontal resolution. Anybody knows that. And so we knew we could get what we needed with those speakers. So I wanted to break it up into an additional ring, and that's what I proposed was I can't remember what we named the new one. I have it here in my file. The names are now Horizon.
I think it's
Sky.
orbital.
Orbital.
Sky.
Orbit.
Zenith. Oh, that became Orbit. Okay.
Yeah.
And then the Zenith. So if you want to move over to my screen at some point, or you can go.
Oh, yeah. You're prepared to
Um,
share? Oh, yeah. Let's do that. You've got good stuff. Thank you.
Okay. So if I go back to Zoom and I say green light, and I go here.
Yeah. And so to remind everyone, because I don't know if we explicitly stated it, the previous system was a ring of 12 on the horizon. And the next layer up was 8 that didn't fit evenly with reference to that 12. So it was 12, 8, and then there were 3 at the very top for that narration.
Right.
And that was our 23. Yeah, go for it.
And so one of the things that Peter discussed was that he wanted to be able to move things and have something be at, say, 3 o'clock and be able to move it and it stay at 3 o'clock, but move up. And if we have it in this, I'm going to change this configuration to stagger. Now you can see them staggered. And now it would go up and then go over here and then go there and on its way up. And of course, what that means in terms of speaker summing is for me to move that up. I'm in one speaker, then I've got to sum together 2 speakers in order to get the image to stay there. And then I go back to 1 speaker. And
now my experience, which goes back a bit, but you've designed and commissioned probably almost as many systems as I've had cups of coffee in my life. And that's a lot of systems. But back in the old LCS days, they were all triangles, right? They were not vertically stacked because my understanding is, the math engine, of that LCS engine worked with the triangles, and vector-based amplitude panning really kind of works with triangles more so than stacked images. Now with ambisonics, usually likes more of kind of columns, and Dolby likes columns. Are you seeing that columns are actually totally fine, or is it because like this venue is specific and the way that Peter mixes across the dome, it actually made sense to use columns?
I think that this is particular to this case, but there is still triangulation going on.
Yeah.
Because there's all sorts of triangulation between all these things because you're still moving things between. So it just pinches the triangle when you put something exactly on that line. And the thing about this, what Peter wanted was to be able to move things, like I said, without it without it getting wider as it went through this transition. So because this is going to be a really truly fully multi-channel system, the whole idea of this thing is that any one location can be the source for the whole place. So what you're going to find is that every single speaker is aimed to cover as much of the room as possible. So I'm gonna have to move, there it is. This meeting is being recorded, okay. So, you know, what I've done here is showing you the coverage of just this single speaker covering this whole room. So what this tells you, if you turn on a mono signal into all the green speakers of this circle, you would have yourself a first-class mess. It's just like, that's an act of sonic sabotage. It's made so that this one covers the whole room, then you can move the sound this way and it covers, and this way it covers. Now you notice, of course, it doesn't cover fully behind itself. That's kind of impossible. And so for those, the LCS will know how to do this, is going to be able to bus smaller amounts into these other speakers to supplement that area, to fill it in enough. And that's where your triangulation panners are gonna come into play.
So I want to pause. I don't want to interrupt or discontinue. So this system, just comparing what we're looking at here, which is identical. This is the system that was installed. So the first system was a 12, an 8, and a 3. This system is a 12,
Yep.
a 12,
Yes,
a 6,
yes.
a 3 for narration, and then a cherry on top.
Yes.
Yeah. Go for it. I just wanted to.
So each of the 12, 12, and 6 are designed with the intention of covering the maximum amount of the room that they can. And as you get closer, as you get lower down in the room, you know, your capabilities change. In this case, by the time you reach, I believe this is the horizon, now your challenge is getting all the way to the other side. And when you move up to the sky level, you really do great. You can really get the other side absolutely beautifully, and your own side in front of you, but you can't get what's behind you. So this would have some supplement on the horizon speakers would help you out here in the LCS. By the time you reach here, you're up high enough, you're angled down so low that you're able to actually cover more of the room, and you can see why that is. And the speakers that we're using here, this is called an X40, and this is the son of, well, it's the grandson of the UPA, and it's the son of the UPA 1P, but it's wider than either of those by quite a bit. It's 110 degrees, and it gets all of those 110. I did manage to prevent the marketing people from calling it 120, which they thought was a better number. I said, no, 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 no. Make it the real number, and we can really say this is what it is. And it's a beautiful 110, and that fills up this space really nicely. So that's what you have here, is this 110 by 50, 110 by 50, and then this being a UPQ D3, which is an 80 by 80. So it's a very, it's a kind of speaker it's an overgrown ceiling speaker. It's actually developed for the tents in Cirque du Soleil who needed things on their masts to be able to cover really large areas from a single spot, because they do a lot of spatial audio. That's where got a lot of my spatial audio work was Cirque and Disney. And so this, by making that circular pattern, you can see, I'll shoot that again. You see, because you're dropping a circle from near the top of the circle, that really gives you a great way to do that. Now, then when you turn around and you do these guys, they're a different mission. Their mission is to cover their side alone. And I'm on a, that's a powerful.
Yeah, so what can you talk about, because we didn't actually cover or discuss what that final location and orientation or aiming of those 3 narration speakers are. We left it at the demo, the test.
Yeah, I don't know about this demo. This one you talk about where the snake versus the MSO with the MM4. Either I need to go to the memory care center or I was not there.
Maybe you were on the weekend. Oh, maybe you were on the weekend, because I thought you came in and demoed one of those. Maybe I
I
need to
could
go
have
to the
demoed
memory
this,
doctor
but
then.
not.
Okay.
I was not there for. I didn't meet the anacondas until it was time to measure them.
Okay.
So here's what you see now is 3 speakers facing outward. Okay.
Yeah.
So this is the old school way of doing it. They're not that far from the old positions. And one of the tricks is that we had to get them really carefully placed amongst the ribs that are here. And they're flipped so that the horn is down as close as it can go. Because as soon as you put the horn, if you angle the speaker to get it right and you have the horn up here, then you're going through you got a million ribs in the way. So we got ourselves where we're right down on those ribs. I mean, literally we had the guys, Ed Sullivan, up in the ceiling, like giving me another inch and moving it over an inch to get me on the spot where the horn could sit in the hole. And that was the whole battle of those speakers. And once they were in the right slot, then they could do their job and Tom Hanks could talk to everybody. So they're made up to be a mono system. So I'm going to turn those on all together and you can see what they do as a mono system. And I want to talk about the colors. I'm not using marketing prediction colors. I would get fired by the marketing department. There's just 24 dB in this scale. So everything red is inside of 6 dB. So you are very much, and this is a 1 dB increment. So you can see we are very much covered all the seats. So everybody gets the voice of God from that spot. But it is a mono delivery. There's nothing spatial about it, because if you just turn on this one, these people know that they're being talked to, and these people wonder why everything seems to be just coming late off the wall of the opposite side. So this is not spatial. This is your narration channel, period. It can do other stuff, but you have to know that it's going to just be, really has to act as a mono block. But from a vertical point of view, this character is not that many degrees apart, and he's ready to play space games. And that's the nature of, that's the way that this whole thing is designed. And
JJ has a question, and then I have one too. JJ says, can you say what effect the grid and screen had on the polar pattern?
Well, when our measure, any ribs that were obstructing the speaker did exactly what you'd expect, and we repositioned those speakers that had obstructions. And I gotta really give a shout out to Ed Sullivan and his crew. They were super patient, because we did not sign off on anything until it was right. And we ran the microphones through and measured these things through their, not just where they're pointed, but we measured all around the room. We had 6 or so mics around the room, and we got a real good feel for the pattern. We were not at all, we didn't find that the screen was scattering us in any way that was bothersome. And it was basically some high frequencies that we had to push up for the screen, but that was it. We felt good about the spatiality on that.
Cool. And my question was, the X40 is an extraordinarily wide speaker coverage. Did that get developed? Was it a happy accident that it was developed and then available for use, or was it developed because of this need?
Well, the X40 was developed because we got some very serious horn math devices at Meyer Sound, and we really upped our game in the horn. We were able to find that we can make a 110-degree shape that had what I call the shovel shape. And I'd have to, what it amounts to is, if you think about your on axis is your 0, and you go, if you're 110 degrees, you go 55 degrees and you get to -6. Well, that could be every 10 degrees I lose a dB, or it could be that I go 50 degrees and I haven't lost anything, and then I lose 6 dB in the last 5 degrees. Of course, that was pretty much impossible, but the UPA1P was very much in the I lose a dB as I go kind of thing. I call that a beam kind of shape. It's a very rounded thing. And the shovel shape is that in the first 100 of the total 110 degrees, 85 of them are inside of the 3 dB, and then the remaining, or about 80 of them are inside of the 3 dB, and the remaining 15 on either side. Did I do my math right? Yeah, about 12 and a half, or whatever it is. If 85, if 80 is let's call it 85, then you got 10 degrees either side where you lose the next 3. It's in that kind of paradigm. I don't have the exact numbers in my head, but the bottom line is that you have this gigantic sweet spot, and you can see that on these pictures that show the performance of this thing. If it had a beam shape, you would see it. I'm going to go back to the overhead view. If you had a beam shape, you would really be able to tell kind of a hotspot. You would see a more gradual turn around. Instead, it hits, and then it kind of loses it all in a very sharp way. And this is what's in the a whole bunch of our products now. We've really come to favor this type of horn in the horizontal plane. It works really, really well.
It's extraordinarily even.
Yeah, and
it's amazing.
Yeah, we just don't. One of the things, whenever I do a demo, I say, okay, I want you to walk around and find the bad spot in the polar pattern, and they come around, they walk really carefully, and then they come to me and they say, okay, I give up. Tell me where it is. I said, it's a trick question.
Thank you.
So the basic idea, it's really very simple, and it's repeat. It's just that we have enough. You're on hourly movement on the lower sections, and hourly movement is what is that, 30 degrees, and so that fits really well in terms of localization, that you're able to run this thing. If you run a signal around that circle, that it runs very seamlessly. It's not a large enough leap that anybody finds that one speaker drops off before the next one comes in. So then you repeat that again in the sky level. And then when you reach this orbital level, by the time you come up, yes, it's just an 80-degree speaker, but it's farther away. There's nobody as close to these speakers as they are to the other ones. And the spacing is coming together. So even though it's by an angle, it's on 60-degree increments, you're shrinking as you get higher up into the sky. So no one's able to detect that one either. And you just didn't really need to go to 12. And we wanted to keep it with to make it a division of the previous ring, so that you could bring those things up and down in the most transparent way. So that's where that all comes to. Then the low frequencies, and we are grateful to the beasts of burden that got that thing up there. it's the 21-inch driver, the 2100. If you've heard this device, it's the first time you really hear low frequencies completely accurately reproduced. And it's a bit of a paradigm shift, because at first you think that's not very loud, then you realize it's just really accurate and not blubbering around like so many other low frequency devices do. And that's a nice thing. It gives a great impact when you want that. And of course it can make sustained noises, but it has its impulse capability is quite amazing. And then we have on the north, south, east, and west quadrants, we have a spatial sub. So if you wanted to move things around that have low frequency content, that can happen too. So the low frequencies can move to the floor, to the ceiling. They can move around the horizon. And then if you put them all on, then you can bathe the whole space in low frequencies. So for the aiming point of view in the design, the basic principle is to aim them for maximum, and you can see them all running through the center, of course, horizontally, everybody runs through the center. And I'm gonna just take a moment and take away the sketch up here, or I think yeah, and just come down to the speakers. We all know what that looks like, but this is where you can see the aim concept. Everybody is going through the place where nobody is, and they all are aimed past the center. They're aimed through the center towards the opposite side, so that everybody has always got their high frequencies going in that range. You're using the directionality to get your farthest throw, and you're using the underside of things, the vertical, the soft belly of the underside, to keep the level uniform at the closer seats. The closer seats they're louder on one hand because they're closer, but they're softer on the other hand because they're of the directional control. And that's the basic principle. So that's kind of it for me on design, unless you've got some questions and things.
Can you recap why there's that consistent blue area around the perimeter?
Oh, well, this particular one, this speaker is, who's on here? That speaker, see, if this guy is covering the other side, for me to cover, if I wanted to have this speaker cover that area.
Yes.
Okay, now I got to do this. I'll do the old overhead speaker aiming, almost straight down. And now I've got it, but look at this.
It's over there now.
I've lost 100 people, and I got nothing. I can't, here's the difference. If I covered these people with a different speaker, it's going to localize to a completely different place, because I have to cover it with something over on this side. And this is why this is chosen like this, okay? So if I go back to my original aim, this speaker right here, the next level down and the next level down under that, which these are the MM4s that lost the shootout with the snake, okay? But they're going to cover the same area. These guys would come into the game and they would start to cover in that area, or this guy at a lower level can cover in that area, okay? So if you put them on together, oops, let's see, hopefully I've gotten yeah, see, now I've extended, I'll do this again. Maybe I should go overhead and be a little clearer. Make sure I'm on the same, okay. We'll take this rib right here. So you can see how much I need help on. Now I can add this guy in, and I've extended and filled that in. Now, so the people back here, people over here are still going to localize towards that. They're going to image in that way. The people here still get what they want, although it's going to be pulled down a little bit because there might be picking up some of that, but it's still behind them. It's still in the same general, it's still at the same clock hour. Whereas if I shoot that thing way down, then it's going to come from the opposite clock. And then the Anakondas, which are, I'm going to simulate here with old school MM4s, they finish off that area underneath. And those guys, the areas under the soffit, they got what they got. And there's just no, they're going to way get the guys on the opposite side, but they're going to get, for this guy there, they're going to be supplemented by, so they still get spatialization. They would still look towards they would be coming behind them, but they would also have something pulling them up, and they get a little bit from this also, because all those are in play. That's the beauty of Space Map, is it sends a signal, and these things are linked to it in appropriate level scaling. That's where those triangles come in again, and they would color that in like that. So,
and does the visual cue in the audio, in the video, that the source is in front of them there, does that overcome the physical sound coming from behind them, since we don't have a front to back perceiving as much as left to right?
I don't understand the question.
The speakers that you have are pointing away from the people in the back row, the last row. The source that you're highlighting is pointing to our left. That middle speaker, the green one, was where you were
around. So okay, so there it is now. Okay, so the current sound source is, we could call that east, or we could call that 3 o'clock, right?
Yes.
So if I'm over here, I'm looking and I'm going to say, sound is at 3 o'clock.
Yes.
If I'm here, sound is at 3 o'clock. If I'm here, sound is behind me because I'm seated at 3 o'clock. And if I'm here, I'd say sound is overhead, which should be where it is on the screen.
Right. But the people behind there, where there's the two MM4s or whatever, right?
The snake people.
Where your arrow is, it's the sound should be coming from in front of them, but it's coming from behind them.
That's correct.
So presumably this is part of a video presentation, is that right? So the sound is coming from...
Well, those people they get sound, but it's not coming from the right place. And as Luke went through, it's like, hey, the people under the soffit, I mean, that's just like tough break, Betty. If you want everybody to have perfect imaging, the solution is yank those seats. I'm serious.
I was wondering if somebody had actually had the political incorrectness to suggest that.
Yeah, that's what we're doing is we're giving them the show, but you can't give them the show with the imaging because it's literally not possible. They've got a cover over their head.
Is this perceptually better than it was before for them in the last row?
Oh God, yeah.
Huge. Yeah. Well, I'll get into that when we get maybe into the commissioning aspect, because that was really, that is part of the question though, of like, okay, we've got it aimed. Did you have more to share, Bob? Sorry,
No,
I didn't mean to.
No, that's it. I voluntarily became selfish and stopped sharing.
Okay. That was fantastic. Thank you.
Oh, there was one more question from David Gilfillian. Is it possible to model the, quote, detectability of individual speakers?
It may be possible by somebody else, but it's not possible with the tools that I have.
Yeah.
Given measurements, yes, it's possible.
Which measurements, though?
Well, you have to, probably I would do a complete XYZW measurement at a spot, and then it can answer the question. And I can also answer it with the other speakers going, but that depends on having a knowledge of what's going into the thing you want imaged and the measurement at the room. And then you can figure out if it's above the masking threshold. So I didn't put a simple label on this.
Yeah, no, it's not simple. Yeah, that's similar. And I saw there is and I need to look at it again, but I think it was about a year ago through CEDIA, which was interesting, are developing a measurement system that is trying to kind of quantify somehow the spatial capabilities of sound systems. It's more geared towards kind of the very high-end home theaters. But there's some tools that are being looked at to do that. Because the spatial, yeah, I mean, we have distance, we have the type of sound, the masking effects.
Well, the trick in this is to basically handle the masking effects and also handle the spatial effects, because it can be tricky to deal with the whole question of cocktail party effect. And of course, that only applies for people with two good ears. Yeah. The answer for people with one ear and the people with two ears is quite different.
Yeah.
Anyhow, okay. I will bow out again. I just had to ask.
Yeah, no, that's good. And well, we can, this is a kind of the theory part that will surface again during the commissioning aspect of it. And yeah, love to talk, and we can drill more into that. So we have, where are we? We're a couple hours into this, and we still have to build the thing, because now we've just got it designed. So Bob came to us. He says, this is the design. We liked the design. It made sense to us. We talked about the theory, the approach, kind of just all of what you saw presented to us. Yeah, let's do it. Now we've got to find someone to build the thing that is crazy enough to be able to take out all of these speakers, get the multi-100-pound loudspeakers off of this dome, and then install the even more multi-100-pound subwoofers on top. Let's see. Let me jump back. Oh, one thing I wanted to. I know the image. It's this. So in the map file that Bob just shared, when he turned off that dome, we all saw the similar inception kind of radiation point, reverse radiating point of that very small point in the middle of the dome, and that, amazingly enough, coincides to the center of the dome, which is a little bit above where the Zeiss star ball is intended to go. I think the Zeiss star ball is exactly, because this isn't 100% hemispherical. It is a few degrees. It is a few degrees up, but that center point is right around here. And the way that was achieved, we'll discuss when we talk about the installation. So without further ado, let's see. So the rest of the system design. So that was loudspeaker, but we have playback. We have file transport. Sorry, we're continuing. My the location of video just changed, so I wanted to make sure I was still sharing. So we have the electro-psychoacoustic spatialization transcoder. I like that one. That's how we're going to get those 23.1 into the 40 loudspeakers, because now we've got the what was level of 12, 8, and 3 is now a 12, 12, 6, 3, and a cherry on top. Different elevations and different quantities. Once we thought about it and discussed it, it actually seemed quite simple. We can just deprocessing, right? So those 24 files have the filters and EQ in the printed tracks. The previous system was Dimitri. The new system is Nadia. We were told that the processing, the filter sets, the delay, the way that all the math works, the equations are the same between the two. And we have those original files, so we were able to just reverse the filter settings and the EQ in order to get us some deprocessed waves. And then that is put into SpaceMap as virtual loudspeakers playing through the actual loudspeakers. This is still yet to be proven. We'll get to what we did in a second, but this was the idea for taking all of those old shows, being able to just put them through the box and then outspits what we want. So Audio Solutions events, modern and flexible. We're using Nadia and SpaceMap. The new system has programmed presets for mono, LR, LCR 5171, and ambisonics. Yes, ambisonics. The spacing of those clock face locations, so the 12, the 12, fit quite nicely, as you know, into the standard LCR 5.1 and 7.1 spacing. They align within the tolerances of where they need to go. So that works fantastic. For the ambisonics and wavefield synthesis and the kids, we gave them Spat Revolution. So Hugo's baby. They got some more wireless microphones, channel increased. They have BYOD analog. They've got some RMA interfaces if they need kind of a higher channel count with their computer, or their computer doesn't have an audio output or whatever, you know, that BYOD could be, because sometimes they just have lectures and someone's got a video on a laptop that they bring in and say, I just want to play my video, but it has sound. There's also open channels on AVB and Dante. We haven't talked about really signal flow, but we'll get into that. And they can still do a one-to-one takeover of all of the loudspeakers via AVB or Dante. And the front of house console in the pit is identical to a portable console. It's the Yamaha DM3?
DM7 compact.
DM7 compact. Totally off. I apologize. That was wrong. Control system, Medialon. Medialon is the museum standard, and they do all of that control and programming for interfacing between all of the systems, as well as just the control panel for services to start the show, stop the show, call for help, wireless microphone, unmute. So it's designed. We can talk more about signal flow. We'll do that in a little bit once we get into this. But we had to find someone to build it now. We haven't even baked the cake. We found the recipe and we've mixed everything, but it's not even in the oven yet. So we created an RFP, a request for proposal. It went out to selected vendors. GMP, guaranteed maximum price, was established. It was unwavering. There was a budget. We had to stay in budget. There was no penny above that budget. There was no contingency available. So in conversations with what can we do to solve all of those problems, there was a money factor that needed to be considered. Also, the design, as good as Bob's design was, and all of our thoughts, it still wasn't 100% constructible document. There was still a lot of we don't know what we're really going to do for the soffits. We knew that soffit fills seemed like a good idea, but it wasn't actually. That photo of the in situ testing happened after by the integrator. They set that up. So the design wasn't final. There was a 53-page document that described everything, but there still wasn't 100% constructible set of documents. There were no solutions for acoustics. There was only the problems identified and the request for the solutions to be provided by whoever is going to install it. And there were only virtual predictions for performance. We hadn't actually thrown a box up in the screen and figured that out at that time. So what we needed was a partner, somebody who could be flexible, work with us, was smart, and able to present ideas and also roll with the punches. Another aspect of that was to protect and serve good sounding audio. Protection of the venue got its own page and a half in the contract. The screen you can't drop anything on the screen. You can't get the screen dirty. If you drop a wrench on the screen, that panel needs to be replaced because there's a dent in that screen. That is very difficult to do, and the time it would take to replace that panel was more time than the construction project had, because there was also a drop dead deadline for completion. The projectors, there are 6 of them. Not only a projector the size of a small car, but a rack next to it. There's 6 of them. They are serial numbers 1 through 6. They are irreplaceable. Those had to be completely protected as 100-pound boxes are being lifted above them. And so what happened was sequence rigging by elevation layer. So they really brought it down or broke it down pretty well. I don't have a slide. I thought I had. So what happened was Claire Global was brought on board with a general contractor. So general contractor would handle things like electrical, because the additional Meyer speakers all needed electrical connections. They are powered. The acoustics work, that's not really Claire Global's forte. And some of the more logistic rigging and some of the rigging was also handled by the GC, but Claire Global really had the bulk of the installation. That was Howard Hinsmith and Ed. Oh gosh, what's Ed's name? I forgot his name. What's his last name?
Ed Sullivan.
Ed Sullivan. So sad. I just saw him a couple days ago. Those were the 2 kind of main people on the project. Those were the 2 that interfaced with us the most. There were a lot of others behind making it work, but boy, Ed and Howard, they jumped on it, and we met weekly, sometimes 3 days a week, 3 meetings a week, logistics meetings, rigging meetings, and technical audio meetings. So broken up in order to finish the design, get shop drawings done, order the stuff, get the stuff in, do a pre-assemble of the rack in the warehouse, turn it on and test it, make sure it works, flesh out any problems that you find during that, and then be ready to have boots on the ground for a complete demolition of the loudspeakers and installation of loudspeakers, pathways, playback system, acoustics in 33 days. It's a big challenge. In situ tests, there's the narration, there's the UPQD3, which, sorry, Bob, I think maybe you were there with Russ and you found like the spot. You're like, I think it's there. Maybe that was it. And maybe it was just like Ed up there wrestling that loudspeaker. But we did some in situ tests with the Meyer MM4 and the KRA Anakonda. The MM4 is a more full-bodied type of sound. However, aesthetics, it came down to aesthetics. The size of the MM4, and I mean, I'm trying to find that photo. Oh gosh. Well, it may be gone for now. The size of the MM4 and how originally we were like, great, MM4, we have the soffit, put a hole in the soffit and stick it through. There's just a screen on the other side. It should be easy. As we started very gently peeling back layers of that plaster soffit, quickly realized we don't want to touch that thing. It would be a mess. So we knew that whatever the solution was had to be surface mounted. It couldn't be hidden and installed, which meant if the MM4s were used, they would be on an armature reaching over the top of the soffit and facing back towards that back row, catching a little bit of that second row.
And the MM4s are about 4 inches cube, roughly.
Yes, they are about 4 inches cubed.
Yes.
And the Anakonda?
The Anakonda is about 2.5 inches by about 1.5 inch by almost a meter. It's
By 50 feet if you buy enough of it.
Wow.
sound by the linear foot. Yeah.
So it's variable? Cut to length?
They are
Just
in
think of rope
segments.
light. Just think of rope light with speakers in it.
Yeah.
Yeah.
Amazing.
Yeah. Yeah, we'll get to that one. Let's see. So we did the shootout, the MM4s with the armature in how they were just situated, cut into the view of the screen. And so with the lights off and an image up every few feet, 6 feet or so, I think was the spacing, you would have this 4-inch cube that's a silhouette blocking the image. And that ultimately was the driver, we'll say driver. That was the driver to not use those.
Whereas
So we
the K
decided-
arrays were behind?
Yeah, we'll get to that. That's yes. Yes, the K arrays we did something fun with. So shop drawings, yeah, we can let's see. Now we do the shop drawing. So we went through the shop drawing process. It was rigging, facilities, speakers, line diagram. We can talk about signal flow as well. We haven't talked much about that, but we can get into that maybe later. Loudspeaker aiming and repeatability. So this was a big thing where all of those converged, those loudspeaker aiming points converged into the center of the room. How can we do that? Well, we use lasers. No ill-tempered sharks, just the lasers. And on the back of each of the loudspeakers are the coordinates, lasers and protractors. There's a tool they use in order to measure the angle of them. And behind each loudspeaker is those settings. So that if it ever has to be removed, if it is going to be reinstalled, you know exactly where it needs to be aimed. The rigging, we'll look at the rigging. This was cool. So this was a big part. Claire Global works with a company, Rigging Dynamics. And Chris with Rigging Dynamics was a genius. These guys were fantastic. They figured out the most elegant solutions for these. And this looks kind of crazy, but this is much less congestion of cabling and connection points than what the fewer previous loudspeakers required. And so for each ring we discussed, we met, figured out kind of what would work best for the layers of speakers going up. The second ring, so the horizon, and this is the sky ring, it turns out that the elevation of those loudspeakers coincided really nicely with the catwalk elevation right here. So they came up with a mounting strategy to mount the loudspeaker using the grates of the catwalk all around. So that reduced the requirement of additional rigging points high up in the sky. And this was all before they got on site as well, of course. The next ring up is a ring, an actual ring, a shower curtain, if you will. Very robust shower curtain, hanging these loudspeakers and the rigging points. These rigging points were interesting. Again, the only existing documentation for the dome were these 3 sheets. And these 3 sheets show something interesting here. We've got some kind of piece of steel and a hook, an equipment hanger stub. Well, that sounds promising, but there's nothing in the final construction that looks like that. There was no record of what the hanging points are, what weights, what this steel is, the capacities for any of these mounting points. And there are dozens of them. They are all over the place. They looked in the city records, couldn't find them. The museum spent time digging through the vaults, couldn't find any structural drawings. And so the GC contracted a structural engineer, and they did an old-fashioned pull test where they attach some equipment to one of them and they start cranking the weight to find out how much it can hold without any stress at all. They did not, it wasn't a to failure. It wasn't an actual to stress limitation. It was just, what is the amount that we can get to that would be safe, that we would sign off on, that also satisfies the amount of weight, which will be put on by, this ring with a bunch of speakers on it. And they got to 1,000 pounds, and they scraped a few off. There was enough scraped with samples and similar construction that the structural engineer was able to sign off and say, yeah, they're all going to be fine for 1,000 pounds. So that was another moment of, I wonder if this is actually going to work. Similar for the narration. So these are the 3 narrations speakers above that. And this is a fantastic aluminum I-beam truss system, trapeze, at the very top above the dome. This is the new installation. So they were able to get these 12-foot spans of I-beam on the top of the dome, create the truss, and all of the mounting that goes with it. There were the first few days were kind of Spider-Man days of people harnessed and flying around and setting up the rigging points. They had a series of pulleys and stages in order to get equipment down and then back up on the outside of the dome.
Amazing.
So, yeah.
There was a picture, the drawings that you showed earlier of all of the speakers. They had 2 cables coming down for support, and then one coming down to the center of the yoke with a line lump in the middle. What is that lump right there?
Oh, that is vibration. That is a it's a spring.
It's a dampener. Yeah.
What does it do? Dampens shaking?
Yes. Yeah.
Huh.
It essentially, yeah, it's basically acoustic isolation from the bar and from the rest of everything.
It's
So
the
every
structural
loudspeaker
isolation, yeah.
has the acoustic isolation. Yeah. So the bulk of the weight is actually in this middle one. When Bob was talking, and we tried to get those as close as possible. Here, I'll get a picture of those 3. And it was me and Ed. I was holding one with one hand, this one with one hand, trying to get it as close as possible. Yeah. Nope, this is one down. That's not the narration one. Yeah, with one hand trying to get it as close as possible because we wanted I wanted it to be a ½ inch. I mean, the closer the better. And so all the weight was the center one, and then these two side guy wires were just for aiming. Just for aiming.
Okay. And those are UPQs there, right?
These are UPQs, yes, sir. Yeah.
And those are like 130 pounds or something? 100 and some? So you were holding that with one hand?
Yeah, I was holding that with one hand.
Nice.
It was strenuous. You want to talk signal flow? It'll go quickly. Final design, very simple. Here's the show. Here's the show. We've got 2 Nadia control processors. There's 2 of them only because the requirement was redundancy. They are hot redundant. They aren't sample accurate tracking. There is, I think we were told about 45 seconds or so for them to actually switch over because the network has to remap and reassign signal flow. It's mostly on the network side. It may be faster than that. I don't know if I ever saw the failover test. But playback of the show, we have the tracks in Nadia playing back on wild tracks on both decks, tracking time code in real time, being spatialized in real time through space map. And then those outputs through the matrix go through AVB if it's to the X40s. And if they are to the K arrays, which there's 23 of them, we'll get to what those look like in a second, then that goes through analog, and the LF900s, those 4 low frequency, those subs that are at the cardinal locations lower, those are analog. The UPQDs are analog as well, and the 2100s. And that's the playback. That is very simple and very elegant. It is kind of minimal parts with redundancy. So that's great. The events system complicates it a bit. Events lives in Dante land. So we've got wireless microphones that are Dante. There's a mixer. There's some events recorders that are Dante. There's an events PC that is running Reaper and SPAT. That's the EarCam, spatial audio, and ambisonics. That's all going through Dante at 48K in order to get it into AVB LAN. Through the AVB LAN, we're using a Prodigy MX, and it works great. And then the show production is only used, some additional I/O, only used during show production, but normally Pro Tools rig isn't connected, and those are additional I/O for events. So it's a as like capable and seemingly complicated as a, I think, 63 loudspeaker system could be. It's actually quite simple on the signal side. It could be a lot more complicated. We'll say that. And here it is. Fits in one. Yeah, there's Claire's badge, and there she is. Single rack. There's an additional rack which has a PC and some other accessories and peripherals for the events system and for monitoring. There's a Dante 1RU audio monitor, so they can monitor any channel of any source. But other than that, that's the brains and everything it needs.
Before we get too far from the pictures that might answer this question, Luke Lassiter has a couple of questions, which actually beg another question. But this first question is, how did they get out over the screen at the top? Which kind of begs the question of how did they get around the curve at the sides going horizontally?
For the installation?
For the installation.
Yeah,
And
there
then,
were I wasn't there for the installation. I got a few videos that were kind of rough to see. Let's see, I'm looking for a photo. So this could work at every landing. There was a series of pulleys that were assembled, created, that attached to those mounting points above, because those are everywhere. That's a mounting point. That's a mounting point. That's a mounting point. Those mounting points were used to create this system of pulleys that eventually ended up at the ground, but has kind of a one stage where either manual or electronic or electric, and got everything up there. Russ, are you still on? You are still
I
on.
am. Yep.
Were you able to see some of that in action?
Yeah, I mean, the main thing to keep in mind is that we keep talking about the projectors. There's six of them, and
Yeah.
so there are certain areas that would be a safe zone. So where a projector was not, could be used as a landing area for the speakers to go up and down. And the other thing we didn't really touch on is that there's a chain fall and another door, another access point where they can bring the speaker up to the cove area. So there was a gang of guys essentially staging this, and it all had to work together perfectly. It was a real team team action kind of a thing on the part of the riggers.
Yeah.
So everything had to be staged perfectly. The speakers had to be where they had to be in the building. Like everything had to be staged just so. And then, the plan of action was remove all the old ones, get them all down, and then slowly bring the ones at the top up first, obviously. The X40s, because they're pretty compact and movable, were less of a challenge, but nonetheless still a challenge. But the biggest part of the job was the stuff at the top, and that's what they focused most of their action on.
Yeah.
Uh, it was
Part
quite a
audio.
feat to see how it was done.
Yeah. Part
And
audio
and to
installation,
yeah,
part
to
circus
anchor
celestial.
the pulley going up and down, they actually had brought in some steel up to that catwalk to the lowest level and actually had anchored the pulley system. So there was some weight at the bottom to bring them up with, because obviously they weren't going to trust the hanging points to do that.
Amazing.
Yeah. Here's that cherry on top. I keep referring to the cherry on top because that's what we named it in the contract. Off-centered, but at the very top. And then this rope over here is, I think, some of the leftover from the rigging that is left in place. But, all of this turnbuckles, this is all vibration suspended. For
Those are the
subs.
two 2100s.
These are the two 2100s. You got it. Yeah.
And is
And they
that
did a great job on that. That is built on a suspended I-beam frame that allows the speakers to actually be rolled back towards the catwalk if they need to be serviced. So they actually did a little bit of construction up there as well.
cool? Was that sign A59 with the two squares around the is that some kind of locating thing
Yeah,
as well
so
as a sign?
after everything was done, they actually did another LiDAR scan so that we could get the exact positions of the speakers mapped. So that those pictures have actually nothing to do with the installation. They're just the post installation LiDAR scan.
Yeah, the Spat Revolution software, the ambisonic software, needed as precise virtual locationing of the loudspeakers in the software in order for the math to align. So part of the contract was post installation, a final scan, 3D scan of the whole system was needed in order to be accurate. And I think it's sub-millimeter accuracy with a particular LiDAR camera that they used.
And David asks, since we're pointing at the subwoofers, are they used to extend the response of every speaker or just as an LFE? Or does it depend?
They're actually bus for both. So that they're doing double duty. So they're an LFE channel on their own, and they're actually bussed out from a summing matrix. So they could be used for either or. And there's actually additional subs. There's a quadrant of subs lower in the.
Yeah.
I don't know if you have a picture of that, but the
those 4 around the perimeter?
Yeah.
Yeah.
Let me see.
They were locational, or they were.
Yeah. Oh, I think there's
They're in the
here's one.
drawings.
Yeah. Since we're looking at installation and loudspeakers locationing, we mentioned subs, timing of subs. Bob, for commissioning the system, is there any approach? I'd love to have you talk a little bit about that if you're still able to do that.
Yeah.
Voila. I don't know what kind of
what particular aspect.
Well, I guess when approaching maybe multi-channel or this particular venue or a hemispherical arrangement, is your approach of what you're trying to achieve different at all than when you would be tuning maybe a major stadium system? Are there some practices, philosophies, goals, measurements of a spatialized system that you really try and kind of work out or achieve that that may be different than a different system? And if not, if it's as simple, I mean, hearing how you approach that on the simple side I think would be great as well.
Well, in any case, that you got basically step number 1 is you got to get the speakers aimed right. In this case, for the commissioning, it was sitting there and seeing that they were aimed right. And some of that was some of that was about moving the mics around, because you couldn't, in our case, we didn't have this great visual that you have here, where you can actually see all the speakers. So we had to sort of figure out that we're on this speaker, and we move mics around and figure out, yes, it seems to be covering everywhere. We didn't find anything, any place got blocked too badly by a rib. So aiming is always the first thing. So then you have, from there you have basically equalization, and level setting and timing. So you set the level so that you basically are making it so that the time mapping, that the space mapping is that the node are all of equal level. Mm-hmm. And so in the case of the speakers that are farther away, they had to run, to make their level reach the ground at the same as the speakers that were closer. Now, in the case of the first 2 rings are both the same model of speaker, the X40s, and they have some slight difference because they're a different height. But then you reach to the orbit ring and you're on a different model of speaker. So every model of speaker has its own sensitivity. So you'd have to work that guy's sensitivity. But basically, I take what I call a gold trace, and I take that at the start of the day, and then the idea is to make everybody lay on top of that trace. So that trace does a lot of work, and that's the case for all system tuning. Is basically my job is uniformity more than any other thing. So we want to make the frequency responses match, make the levels match. And the final thing that you have is the timing. And in this case, the you have a circle of timing. So if you think about the circle of one of the rings, you can't get yourself, you got to be careful of getting yourself too tricky, or you're going to be basically like playing an MC Escher drawing. Because if you think you're going to delay one part of that circle and then come around and delay each one, you're going to find out when you come back around at 12 o'clock that 11 o'clock and 12 o'clock are a day apart. So don't get yourself too tricky. But in our case, we did have some things where there was that ladder that you see there, and that ladder pushed one of the speakers off of its hour. And so it had a slightly different timing because it was closer to one side than the other. But we didn't try to then compound that and keep that thing going all over the place. You can't solve that. So then you have the ring to ring timing, and that's something now you can do something about. And details on the EQ, there was very little EQ. That's the beauty of the X40s and the CQs UPQs. I did take away some of the low frequency range of the UPQs because they simply go further than the other ones. So basically penalize them for good behavior. And that's just a simple case of they can get somewhere that the other ones can't, but because we're all wanting the system for Peter to be able to move his sources and not have it suddenly add some low end when he moves it up higher. So they were forced out in that way. Now, not the same for the dialogue. The dialogue, that's EQ'd as a trio. So in that case, the low ends are going to all couple together, whereas the low ends are basically going to go 360 degrees each, and the high ends are going to go 80 degrees each. So you're going to roll out some low end on that zenith trio. Then the speaker 501 that's in the center, the one that's facing straight down into steel. How did I EQ that? I just put up the white flag on that. Because you can EQ it all day, and it's steel is very, very strong compared to sound waves. And that's good, because if it wasn't, we would have a lot of buildings fall down. So basically there's a timing sequence as we go up, to connect the rings. And where is that done? That's where you're going to pick a location, because this is a case where you have to play God, as I call it, because there's only one place that you can do to bring everybody together. And in this particular case, the only sensible thing that I can come up with is an actual location where nobody is. And that's the very center of the room where where that projector is. And because that's all about the air bars, if I make them the timing wise that they all land there, then the air bars move, they move in one direction for the people closer than the center, and they move in the other direction for the people farther than the center on a particular side. So, if you made your side right there on the very near to the speakers, that's, one thing, and you're going to be far off on the other side. If you make it on the other side, you're going to be far off on the near side. So you go to the center and you let your air bars fall both ways. That's the sad reality. Marketing people hate this kind of thing, because I'm supposed to say I set the timing that solved it for everybody, even though Geometry 101 tells you such a thing is not possible. But I figure that all marketing people all failed Geometry 101. I've always concluded that. I'm very tough on marketing people. So if you're a marketing person on this call, you don't like me. But
You left a long time ago.
Yeah, exactly.
What about timing of the subs? So this is the older system, but the subs at the top and the subs on the side, time alignment with the others, or were there some kind of goosing and differences that you ended up doing that you remember? Sorry for
The answer is that that the subs on the sides
Yeah.
are timed to the speakers that they are closest to.
Yeah.
Okay. And the subs on the center up high are timed on the speakers that they're closest to.
Mhm.
It's an exercise in futility to take 5 sources that are all aimed inward and think that there is a timing solution. The solution is turn off all of them but one.
Yeah.
I mean, it's just simply, or if you just take one, if you give one timing for the 4 low distributed speakers and a separate, and then you time that the other sub for it, where is that going to be? It would have to be what logical place could you come up with? There's the center,
Right.
and that's really it. And since we already timed everything else for that place, you're really going to get the same answer.
Yeah.
That we did before. So essentially, everybody is coming to that point.
It's refreshing to hear. Thank you.
Mhm.
Yeah.
The subwoofer's range is 29 hertz. For the 2100s, it's 29 hertz to 120 hertz. And it's for the 900s, it's about 35 hertz to 120 hertz. But from a commissioning point of view, from a calibration, setting the EQ, the level and things, it was really quite simple because there's no arrays. There's only one array, and arrays are where that's where a lot of nuanced things happen in tuning. In this case, everybody is their own channel, so they're behaving as soloists, and then it's all about aim is really the key thing, and keeping them out from being knocked into by steel.
JJ asks, what are the various low frequency resonances in that building? Do you measure that?
My answer would be yes.
Nice.
I mean, you run a sine wave in there and you find out every piece of steel in that building. I mean, there is so much mechanical works in there that if you run it loud enough, you're going to find somebody rattle at every frequency.
Well, I understand far too well. I was just wondering if you had done anything to control it.
No, nothing that I can do.
The room?
Costs money.
Yeah.
No, walk out the door.
Well, no, but they've done, there's done a lot. There's absorption in there, and as an overall listening experience, it's a really good quality affair. There you go. Look at that.
Mm-hmm. Yeah.
I mean, I don't want to put anybody down. It's a very, very, very well handled.
Yeah, I'd say during normal shows, I haven't noticed any parasitic vibration, sympathetic vibration from either the dome or the room during tests. And when you start putting kind of rock and test energy in there, things start rattling. But for the normal space show, it doesn't. And to keep in mind, Peter mixes in this. He's done it for 20 years. He would also be conscious of that. And if he heard that, he'd go, I'm not going to do that. I'm going to make the choice not to do that and do something different or get the same effect, the same emotional response, the same kind of energy in a different way that still makes the most use of the sound system without creating distractions or inhibiting the experience from other artifacts and things like that.
Yeah, they actually modified some of the sound effects for the newest show as they were mixing because of these issues. So it would just be a matter of changing a few hertz difference.
When we did the Mickey Hart show, we had this speaker called the VLFC that goes from 29 hertz down to 13 hertz, in addition to the 1100 subwoofer, which so that together you had a subwoofer system that we brought in that went from 13 up to 100 hertz. And we found, we found those open holes that you showed earlier in your presentation. They were rattling like crazy. And we went and actually, like, I can't remember exactly what we did. We were misbehaving people, and we like removed the things or gaff tape.
Yeah,
Those grills.
somebody thought it was a good idea to stick a piece of Sentra in there to cover the visual, and you discovered that it was creating a baffle.
So it was bzz, 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 and the VLFC is a great thing for finding any kind of things, because it's putting pure sine waves down really low. So anything that takes that frequency or any harmonic of it is ready.
Russ brought up kind of modifying a new show to accommodate the space and not excite rattles and stuff, which kind of relates to a question Mike Wall asked a while ago. Is the same space and rig used for mixing new show / content? It sounds like, do they do the new shows off-site and then come in and fine-tune it? Or
Oh, no, it's all done on site at night.
Okay.
We actually have built special tables to roll in. So we actually build a small studio every night to mix the show on. Mostly it's KVM. The Pro Tools rigs are in the back room, but nonetheless, it's still an endeavor. And because of the complexity of the mix in the short window, it's usually done in about 6 to 8 weeks at night. We have the sound designer on a secondary Pro Tools rig, so he can work independently of Peter, the primary mixer, so that he can work on the orchestration and stuff like that while he's building the effects. Usually the effects come in pre-built to a degree, but there's just so much that has to be done in the space because you don't know where the trajectories are going to be until you see it on the screen.
Yeah.
Cool. Mike, that was a great question.
A couple other items. There was an interesting aspect conversation for ambisonics on the spatial, because we have a lot of people that said kind of ambisonics in their introduction. They may still be on. There's a fair amount on. It's a good job, everyone. And through the inception of this, going back to 2022 and 2023, in all of the research done to date that we could look at and kind of hang our hats on, were tests up to about third order ambisonics. And unanimous literature studies and case studies, examples, experiments where the audience size needs to be so small for that lower order ambisonics since then, right at kind of the cusp of while we were looking at some of the design, it seemed like there were some breakthroughs. And if any of the ambisonic brain trust knows more about it, or if I say something inaccurate, please interrupt me. The maths required for the truly higher order ambisonics in the 6th and 7th and potentially 8th order ambisonics was finally figured out. And I think more importantly, the processing engines to be able to do that in real time were finally figured out. And so there was a really exciting opportunity to identify, run the math on something like a 7th order ambisonic, where the quantity of the virtual nodes, loudspeakers in the ambisonics model matched enough to the new design of the 12, 12, 6, 3, 1, that higher order ambisonics could actually work for this large of a venue. So we got in contact, Harman and Spat, who purchased Earcam's Spat Revolution, and Hugo. That's going to be, I think, commissioned soon in the next couple of weeks. He's going to try and make it back down there and finally get that going. But that's a really exciting and interesting just venue and use case. I don't know of a theater that has 400 plus seats that is actually showing ambisonics and doing that. I think there's a few out there, but they're more kind of black box theaters and parts of schools, not necessarily a public venue. So I think that's very cool. This will have the capability of doing that. It's pretty neat. Any questions so far? I have like 2 items, and then I think we should be able to do a 5th order for the current line. Yeah, the 5th, we looked at the numbers because it is also hemispherical and kind of reduced hemispherical in order to get the numbers matching, because we knew that this design would work for spatialization, for evenness, for complete coverage, going, harking back, well, where do you point the speaker? You point the speaker everywhere. And for that to work in this particular venue, because the seats go all the way to the edge, we were looking at kind of 6th and 7th, maybe matching better. For a different venue, 5th may work. 5th may work. Perceptual techniques. Yes, yeah, you have to get the systems that do it. Yeah. There are a couple spatial systems out there that, have a little kind of magic sauce and some timings and some kind of phase manipulation that work when used in a very particular way. I think back to kind of Bob's description, this is the spatial sound, right? It's a mono, each speaker is its own mono channel, doing its own thing of complete coverage.
Yeah. I could talk more about it, but not now because that's a week in its own regard.
Some other time then, yeah.
Yeah, it might be interesting. I can't say for sure at the minute, but we'll find out.
That's very, I like that. That's kind of prepping.
Well, I know such a system exists that could handle this setup. The question is whether or not there is any way to make it available.
Yes, yeah. Oh, we're gonna be concertized here. I like it. No, leave it on. Leave the camera on. Here we have an image. So this is the Anakonda. Okay, so we talked about soffits. We talked about the narration problem, the quantity of speakers, where to locate them, how to tune them, where to point them, how many are needed, what's going to create a nice even sound field. We need to talk about that back row again. We never finished with that back row and the final the final solution there for that. And so these are the Anakondas. And what kind of simply was done was a acoustic material, 2-inch acoustic material along the painted plaster soffit that wraps all the way around the soffit. Let's go, let's get that section of the soffit. Here you go, Luke. Is Luke still on? Oh, Luke is still on. This is Luke's drawing. This isn't the exact, this didn't end up being installed, but this is kind of the idea. This was the strategy that he and I came up with, which was some kind of depth of acoustic treatment and then create a channel in that acoustic treatment in which the Anakonda could be recessed, affixed, so that it is solid, not moving, and then wrap the entire thing with some acoustically transparent fabric. So it is a nice, even, finished appearance. And that is exactly what ended up being done. And so the back wall, that small pile carpet, I had the idea that I really wanted, you know, some kind of wood slat to give it a little more life and not just complete absorption. We did a couple tests with samples, 4-foot samples of a couple varieties of some kind of wood slat, semi-perforated reflection and absorption, refraction, all the good stuff. It actually ended up a little too energized. It was too much with that in back. And so that small pile carpet still exists. Those holes in the wall, those are now completely filled in, so the projector noise doesn't have a nice port, acoustic port for that. And then going up above the back seat is acoustic treatment, an Anakonda, facing the back 2 rows, and then that acoustic fabric finishing around the top, so it's a nice, clean, finished look. When Bob was tuning it, he finished early as well. It was amazing. They did it all, I think, in less than 2 days, if I remember. It was just shy of the second day. All loudspeakers, including the Anakonda, and it was that clean sound canvas, right? That even sound field. And what Peter was able to do when he came in for 2 weeks to remix the first space show, the Tom Hanks space show, that was the first one from 20 years ago. They found some original stems. He was able to use those and do some mastery in a 20-year-old, not original, like semi-processed in the production chain are the ones that were found. But he was able to use those. And through timing, I think we ended up with something like 7 or 8 milliseconds of delay on these, so that any of the spatialization was still preserved and perceived from coming in front of you on the dome, the narration, any of the effects, but the sound was actually energized. There was a bit of sound energized coming from that, and it worked. It worked great. I mean, it just like opened up the whole thing, and it sounds fantastic in those back 2 rows. They're one of my favorite seats after listening for 2.5 days while he was tuning it is right back here in the it's row seats 17 and 19, and then 12 is good as well, right there in the second to last. And that back row is actually really fun. There's energy. It's kind of lifelike, and you get to sit in the back of the bus and then just see the whole picture in front of you as well. Because as you get closer to the front, your neck starts doing one of these kinds of things. And even with a 24-minute space show, it's not very long, but 24 minutes of kind of looking straight up. For me, at least, I'd rather not do that. So getting that full picture, yet still the full audio experience is now had by those back 2 rows. So we solved the back row problem too.
Luke, just quickly, I've lost track of where the MM4s are relative to the Anakondas. MM4s are the horizon speakers that are just above that?
The MM4s were the other option of Anakondas. Originally, we were wanting to use the MM4s because of the frequency response, predictability, reliability. That was our choice. It was an aesthetic kind of optical intrusion obstruction that said,
right, because they're peeking over the soffit. And yeah,
you got it. Yep,
gotcha.
yep.
Okay, thank you.
You're welcome. Yeah.
And even if you had mounted them behind people, there would still be these lumps spread out around the perimeter.
Yeah.
Whereas this disappears.
Yeah. Yeah. I have two more. These are kind of fun, and then I could talk more about signal flow and kind of the software side if we want. But this just shows, the 714 and the presets, the 5.1 presets. So everything that we need the system to do are presets that Peter set up that are then recallable by the control system. So someone comes in, they say, I got 5.1. Okay, you got 5.1. Use these 6 inputs, whether that be analog or if they're coming in Dante, there's 6 known to use on the Dante, and that just gets routed through the Dante side of things. Here's a little fun mix matrix. This one's on the Prodigy MX, so our big Swiss Army knife of signal I/O that converted our Dante to AVB. Thought they'd be fun to show you. And with that, all of the challenges, all of the goals, we found solutions to, and all were implemented except one. We did not solve one of the things, and that was making the projectors quieter. Well, we did a little bit, I guess. We filled in those giant holes. There is a design, though. We ran out of time, ran out of budget to create shrouds that encapsulate all of the projectors, and the goal was 10 dB. We knew we weren't going to be able to seal them off. They still need lots of airflow. There's still going to be sound bouncing around, but the modular design of kind of mass acoustic treatment, we thought we could get probably 10 dB of less noise in 250 and above. Somewhere around kind of 250 was a cutoff from the materials we were looking at and the designs. So that's still a design that was figured out, just not implemented. We simply ran out of time and money, but may do that in the future. But other than that, all of those targets of I/O and a spatialized system and flexibility, reliability, gosh, the mounting, it was wildly successful. I had to leave before Peter was done mixing, but I was able to actually go back about a month later with my family. And we spent the day at the museum. One of the venues was this, and we saw it, and it sounds amazing. Like it's fantastic. It's a fantastic sounding venue. Peter really kicked it out of the park. The new show is probably even better. Because they're not dealing with 20-year-old half-process stems that they're trying to bring back to life. So yeah, for all intents and purposes, a very successful project, and so many people involved in order to make it happen. As always, that's always the case, isn't it? So, any other questions? Anything else? Any requests that Bob can, play for us, then we can do.
I had a question about one of the slides that you showed from the inside that seemed to be looking through the screen to see the Yeah, That's what's happening. The lights in the room are off, and we're looking through the thing.
That's exactly right. Yeah, these are in the room, the lights are off, and all of the tech lights on the back of the screen are on. Yep.
Amazing.
Yeah.
How often do they replace this screen?
Just once so far.
But they clean it monthly. They clean it monthly.
Okay.
Giant vacuum cleaner.
Yeah.
Is it really?
Multiple.
From the back, not from the front. The front
Yeah.
surface can't be
Right.
touched.
Right.
Trying to see if there's a vacuum cleaner up here. They leave them on the catwalk sometimes. I don't see them. There's probably one in the model. Yeah. So that's the case study.
How do they attach the screen to the structure?
Right.
Chain hung.
Yeah, that's
So, and it's even. It's not wrinkly or anything. From these.
Well, there's a couple spots where there's some extra tension. A couple of panels are slightly warped, but I won't tell you where.
Good.
I've never
Preserve
seen
the
a
mystery.
That's called a wrinkle in time.
Right.
wrinkle in space.
Right.
Yeah. So there's these chains
not
every what is that, about 10 feet or so, every 3 rib sections. There's these chains with turnbuckles that then go all the way up. If we trace this one right here, you can see my hand, it goes all the way up to one of those mounting points.
Yeah.
We saw at the very top. Yeah.
But then how does the fabric attach?
It's aluminum. They're very thin aluminum, and it's I don't know if it's patented, but they're the only ones that have this overlap and rivets.
Huh. Is the fabric aluminum?
No fabric. Yes, fabric is aluminum. We can say
Okay.
that. Yeah, they're panels. Yeah, so it's not fabric stretched at all. Yeah,
You're
It's
talking about the
aluminum
skin,
solid.
the
Yeah.
projection skin?
Yeah.
That is a Spitz nano seam. It's riveted, pop riveted to the steel structure. And it is powder coated from the factory. Even the rivets are powder coated from the factory.
Huh. Amazing.
Trying to find a seam. I can't. Not in this image. Yeah.
I was gonna say it looks great.
Yeah.
Yeah.
And did you say it was a micro perf in there?
Yes, it's a micro perf. There's actually somewhere, I don't know, Luke, if we can find it, but I don't think we have it here. A time lapse of it being installed somewhere. Maybe Carter has it. So there was actually, when we closed for that, they built a scaffold at the level of the bottom of that skin, all the way across the dome, and then put a scaffold on top of that so that they could actually stand all the way up to the very tippity top and rivet that thing in there.
Trying to
And how much of a focusing effect do you get standing down in the middle?
Oh, quite a bit. It's like a giant satellite dish. So there's certain spots where you can hear a conversation being whispered across the room, and then there's other spots where you hear nothing. So it's just the acoustics of a hemisphere.
Trying to see if I have a cut sheet of that screen. Not able to find it. Updated dome sync. No.
While you're looking, Mike Wall wrote, a wonderful discussion. I can't wait to visit the Hayden again after this fantastic work. It's been a long time. And Fred wrote, thank you for a wonderful presentation. I need to run. Thanks for all of this. Yeah, really. This has been awesome.
Excellent.
Bravo.
Great. I'm not finding it, but yeah. It's a fantastic system, and I think, as you've heard, a unique project in almost every way possible.
Yeah.
Yeah. Well, great. If there's no other questions, we could conclude. Let's see, what do I have? Calibration. Yes, yeah, music stems. Yeah, this was the remixing. 2 weeks.
Who is DJ PH?
DJ Peter Holinsky.
Oh, okay.
The remix.
Mm-hmm. Is he a DJ?
He was, because he had to remix the show.
Okay, got it.
No, he's not a DJ. Although, I don't know, Bob, is Peter a DJ in his off hours, in his free time?
He's a drummer.
He is a drummer.
He is a Tony Award winning sound designer.
Yeah.
Cool.
And he has guitars hanging up on his on the wall of his house. So he's a drummer, huh? Well, that makes sense.
Yeah.
That's people that hang up guitars don't play them.
Questions, folks?
Any more? All right.
I think you did a great job answering questions
Yeah,
throughout.
thank you very much.
Yes, I
Good.
thought so too. And you still have hair, Luke. I mean, congratulations.
Thanks. I think when I've decided, after talking to my kids, when I do eventually lose my hair, because my brother, who's 7 years younger than me, hasn't had hair since he was 20. And
Oh,
my
dear.
dad was not. I'm gonna do the big old the giant white wig from back in the day. I'm gonna bring him back. I think it'd be such a Portland thing. I'm gonna do it.
Cool. Well, Bob, especially thank you for staying up so late to be with us.
Well, Russ is in the same time zone. I
That's
appreciate
right.
you staying up with us.
Yes, thank you, Russ.
And it's lunchtime in Sydney now, so
Look, I actually had a snack as we were going.
there you go.
That's what's so great about this Zoom. I mean, we went straight through, and that's how we do it, and people can do what they need to in the meantime. And we're sitting in our comfortable chair, and we've got stuff near us, and we can get a lot of information passed out. That's really great. Thank you all.
Thank you for inviting me.
Thank you.
Likewise.
Live long and prosper, I guess.
Yeah, so normally we hang around afterwards and chat about stuff. So if anybody wants to stay, you're welcome to for at least a
Welcome
while.
you to stay. I have to chat with the pillow right now.
Yes, thank you, Bob.
Okay.
I'm going to
afraid-
send you
Guys.
I'm going to send you an email next week to talk about something else. So thank you.
Righty.
I'm afraid. Yeah, I'm afraid that real life wants to bother me, so I probably should go ask her what's up.
Okay.
Thanks. Bye.
Take care, JJ.
Thanks,
Thank
everyone.
you so
JJ,
much.
Thank you.
thanks.
Good
Take
night.
care, folks.
Oh, hang
That's
on.
an alarm
Night.
telling me to pay attention.
Big thanks to Luke Lassiter for hanging on as well. He was there at
Yes.
some of the inception of this, and had fun conversations, the two of us, a year and a half, 2 years before the project even went, as kind of brainstorming and thinking and figuring out what it could be. So that was fun.
We'll have
Yeah,
to
and a
do
shout out to Luke as well, because there's another theater in our building, the
Yeah.
Invisible Worlds, which Luke was a big part of, and we could do another whole show about. But
Oh, really? What's this?
well, we'll leave it for another day. But if you look it up online, you'll see it's an oval shaped perforated screen theater with lots of Meyer speakers that Bob was also involved in. So we'll make another talk about that sometime. But just a shout out to Luke, because he was very instrumental in that project in
Should
another
we
life.
Should we reach out to you, Russ, about that?
You could always reach out to me, and you guys
Okay.
are all welcome when you come to New York, and we can see the behind the scenes of all the where we hide the dinosaurs that are alive and stuff. You know.
Russ, I'm coming up to do something next week, so I'll text you so I can get over there and see the new show.
Yeah, yeah, absolutely. Just get my contact info from
I
from
got it,
Luke.
sir.
Great. Thank you so much, everyone. I'm recording this again because this is good stuff here. Okay? Is that okay
Sure.
to record?
Yeah.
Very difficult to get stuff behind a screen in a planetarium. So even though this is a tight space, it's actually fairly generous for for this type of industry.
Wow.
I've been in a lot of planetariums where they have absolutely no space behind. I could barely fit a speaker. Certainly couldn't fit anything on top.
So where we are now in this picture, is this where the shaft terminates? Near here? So you can get everything to this level, but then it goes up from there?
Yeah,
It's even more complicated than that. The catwalk is not continuous. So there's a tech room where Luke had showed you where the equipment lies,
Yes.
and that the catwalk goes above that and then goes back down again. So that it's actually not completely level in the sense. So there's projectors that are at different heights. So one projector is actually flipped upside down because it was on a riser, and that one, in order to get the lens to hit the area of screen, it's actually inverted.
Amazing.
Yeah. Yeah, like you could see this is a lower part of that catwalk, which comparing to the left side is that much lower. So here's smaller projectors for the events, PowerPoint presentations, but here's one. You can kind of see through the screen. This is a projector on the stand. This I think is the upside down projector. Maybe not. And then
It's the
this one
one
is the upside
behind
down.
the
And
yeah.
that one. Yep. So
Yeah.
this is at a different elevation. And there's like on this is the floor right here. There's a chunk of it that's like a 2 foot by 4 foot diamond metal grate that I think lifts up, or it has 2 doors. I don't remember. The rest, you know. You could.
Well, the best part is Larry tells me, "Oh, I've solved the noise problem for the next generation of projectors. The only problem is the projectors are 6 feet deep, so you'll have to build chutes and ladders to get over them." We actually did this before the eclipses were installed. They had given us an interim system, which were the cinema projectors, which are these 6 foot long bodies, and we literally had to build a catwalk on top of the catwalk to get around up there.
That sounds like a nightmare.
It is a nightmare, but there was no choice we had. The other choice was to get on your belly and crawl under the projector, which, let me tell you, in the dark is not pleasant.
That sounds even worse.
Man.
Yeah.
Is there a requirement that you have one hand tied behind your back at all times too?
Well, that's what I joke around about with Bob, was that, every time we look at some oddball thing in the museum, I'm saying, well, can I throw another problem at you? No.
Yeah.
Is there a way I can make this more complicated?
Really? Huh. It's intense.
Yeah, it's pretty crazy. But the interesting part is that, like we were saying earlier, that the riggers were able to, like almost like a ballet, how they organized it. We had to have everything in the right spot for them though. Like everything had to arrive at the exact right time. Every speaker had to be there. Everything
There's
had to
no
be tested.
storage. There's no
There's
staging
no
area.
storage. The staging area is where we have the crowd normally that comes into the theater. We close, we use that as the staging area.
Okay.
Claire had to make sure every single speaker worked before it went up. There was no room for error.
Mhm.
We had a few bumps in the road once they were in the air, but they were all fixable things.
Were you there when the old building was torn down and this was designed and put in?
I came in just as they were building it.
Okay. So
And
the design was done by that time.
design was done. All the major things had been decided upon. The point that I came into it was when they were about to make the first show, and Carter Emmert, who was part of the visualization team, they just did a nice piece on him in the Times. He's retiring now. Brought me into the dome. They didn't have seats in it or anything, or even lights. And he and this other gentleman named Dennis Davidson were flying through space in real time with a F-16 fighter joystick in the middle of the floor. It just blew me away. This is the closest I was ever going to get to actual space navigation. And I said, sign me up.
So when you saw that, there must have been a screen, or were they projecting on the wall?
They did have the screen up. The screen was
Okay.
up at that point. The speakers were still being installed. The seats weren't there yet. It was just an idea at that point.
So the original speakers were put up after the screen was in place. So they had the same problems that you guys had.
Same, but not as complicated because there weren't projectors yet, at least not fully.
Mhm.
And they didn't have to worry about dropping anything that way. And,
Right.
there were some advantages at that point they had.
But the spacing between the screen and the walls was predetermined, was already determined.
Pretty much.
And
And the funny thing is, everything about the theater was designed for the Zeiss, including the paint on the original screen. It was all geared towards the Zeiss projector. The projection was an afterthought. The space show was an afterthought. The sound was an afterthought. It was all stuff that was like, well, this might work, this might not work. But of course, people will be coming to see the Zeiss, and how quickly that got outmoded once we could truly do, stunning video movies, with immersive sound and all that. That was a real game changer.
that opened up a lot of possibilities.
It really did. And I'll tell you, what really hit me was the first time we brought kids in. They brought school groups in to see the show and previews, and to see how they reacted to it. It was stunning. It was like, it was amazing.
Wow. And is this Bob and his team, or?
Well, Bob's on the right, and that's
Bob's in the
Leo.
middle.
He's one of the Meyer techs that works on the Dimitri Nadia stuff. He was at Invocom doing their presentation a couple days ago.
Yeah. And this is Peter Helinski on the far right. Yeah.
All right.
Yeah. So this was in the middle of commissioning. This was commissioning day 1, I think. Yeah.
Yeah,
So
what really impressed me about Bob is that he'll tell you what you'll see on the smart screen. It's like, well, I expect this response. And this is before the thing is even getting pinked. It's, you have to know your instruments. You have to know, and you guys all know this already, but I'm preaching to the choir here. But yeah, it's just great to see when people know their stuff and can come in and say, well, I expect this. And, it's a game of inches at that point.
Yeah.
Rather than yards and feet.
Yeah, I mean, if you're that far off, then your design is not going to work. But it was amazing to see how close we came just from the initial install. and then we just had to tweak it a little bit to get it where it needed to be. And there were a few issues, like he was mentioning, there was a ladder. One of the speaker positions was going to be shooting through that ladder. It just didn't work. So we had to rejigger things slightly to make that happen. You know.
And the ladder is concurrent with the framing for the dome?
Yeah. So
it's not mounted on the wall behind. It's
no.
Correct.
Yeah. Wow.
Yeah, you can see
Bob is really amazing. He was in the measurement of concert PAs at the very beginning of
concert PAs.
Yeah, and well, not exactly concert PAs, but big PAs, big concert PAs, and doing measurements that took a half an hour or a couple days to process on the computers of the time to get to see results. He gave us a talk in about 1992, maybe, or before that even, about the SIM system. And that was SIM 2, which traveled in about 4 great big flight cases, comparatively big flight cases. And now he's doing it on his laptop and seeing it in real time. He's wonderful. There's that ladder.
Yeah. Always in education when you bring him in.
Yeah. Yeah, he taught Meyer sim schools where you go for a week and learn how to use the sim machine. And it was a mind changer, mind expander experience.
Yeah.
Anything else from folks?
Don't think so. I was going to look at the chat just to see.
Great.
Nobody said if anything was missed, but it was relatively quiet, which means I was either putting people to sleep,
Not at all,
or
I don't
covering
think so.
information that they needed. Then, so that
the latter.
Okay, good.
Totally the latter.
Oh, good.
That was really a great presentation,
Okay.
and you turned a huge amount of information into palatable chunks and covered what needed to be covered.
Thank you.
Presented it clearly.
That's great. Thank you.
That was really neat.
Yeah. Well, it was fun to do.
Good.
Yeah, the Invisible Worlds project that Russ mentioned. We were hoping to do one of these at Infocom or AES or some other convention to let people know kind of how that project was done. Talk about a complicated project. That was a whole different. It was a COVID project as well.
I don't know what this is. I may be the only one who doesn't know, but maybe not.
It
took place during COVID, and there was shortages. There was a building being built. It was delayed because of construction issues. We had to have people on site, but everyone was supposed to have a vaccination. But of course, not everybody around the world believes in or wants that. So you could just imagine trying to get a building built during the COVID period of time in New York, which was basically shut down. It was quite a challenge, and still try to open on time.
And was this a building for the show?
It's
an
additional
event?
wing of the museum.
Ah,
So
okay.
an entire wing. It's called the Gilder Center. And
wow.
within the Gilder Center is another theater, which is
Right.
this Invisible Worlds, what's currently called the Invisible Worlds Theater.
Right.
And at the time, Luke Lassiter was part of a company called Solotech.
Yes.
And he was their lead project manager, I guess, Luke, we call him. I forget exactly. Yeah.
Yeah, he wasn't the PM, but he was the lead designer and was And the design part was more important. I'm trying to see if Luke's actually in this photo. I think this is me trying to put my shoes on.
Hmm.
Oh yeah, because you had to wear booties initially. We were afraid of the floor getting damaged.
Yeah. This one has 32 X40s around it, 2 rings of 16 behind the screen.
Three.
Huh.
So it's got a ring of X20s at your feet,
Yeah, and then a
and
ring
then
of X20s.
yeah, and
2
then
rings
ceiling
of,
speakers. It's got another giant sub array.
yeah.
This was Dimitri, so it's the prior generation before Nadia. We really wanted Nadia. It wasn't ready yet. It wasn't even a gleam in their eye at that point.
And
Yeah.
this picture that you're showing us, the
yeah.
one with the grid, that's all focus for projection.
Yes.
Yeah.
So
16
each one of
projectors.
those is a projector, and those are overlapping perfectly.
Yeah.
Yes.
So it's another Christie system laser
Wow.
projector, but they're not eclipses. They don't need black level because it's a much brighter room. But it's an interactive theater. So there's actually IR cameras doing a heat map, and kids can like do things like jump on bubbles, and the Dimitri will make them pop in real time and stuff like that. So
Wow.
it's a cool little venue. Luke Lassiter was instrumental in integrating everything, because we needed to have the projectors talk to the computers, talk to the interactive system, talk to the Dimitri, everything
Wow.
is communicating with everything else. And as what usually happens with folk like that, you're suddenly more valuable than you were at the beginning of the project, and he moved on from Solotech.
Mhm.
There's a surprise.
Yeah.
Wow, this is amazing.
Yeah.
This is really great. See, and this is how we found Luke Goodloomis, is talking after, I think it was the audio precision meeting, maybe,
Yeah.
where we were sitting
Yeah, I think it
around
was that one.
talking and saying, "Oh, what do you do, Luke?" And he goes, "Oh, I did this project." And I was, holy crap, that's a meeting right there. And it was true.
Yeah.
So this is great hearing about Luke Lassiter and this whole business here. It would be intriguing to see how that comes about. That he wasn't doing the PA, was he? Or was he? He or the sound systems. He was doing
had
the
it
whole.
all.
Yeah.
Yeah, it was audio, video, and control.
Yeah.
And
Wow.
there's, I mean, it is AES, but for this project, like there's a few aspects to it that are interesting, and one of them is when Russ and the museum were creating the performance specifications, which for a venue like this actually did exist. So frame rates, color space, subspace, color sampling, and audio resolution, loudspeaker playback, like each of those metrics for each type of product in the venue. So you have playback, you have interactive, so the playback and the interactives, you have signal transport, there's projection itself, there's materials. On the audio side, there's playback, there's tracking of playback, there's transport for audio, and then there's redundance for each of those. There's hot swappable, running in real-time redundance, and there's complete backup systems just in case that primary and secondary fail in the interview process. So I kind of described the interview process for the Planetarium, where we talked to, those 5 vendors and whatever. For this venue, we talked to vendors for each of those categories. It took 6 months of weekly, well, almost daily meetings, because it was COVID. We didn't do anything else. So we would meet daily for about 3 months of interviews and an additional 3 months of follow-up interviews and conversations with the manufacturers. After the end of that 6 months, for each of those categories, there was one product in the world that existed that could perform and meet the performance specifications that were outlined.
Wow.
So at the end of it, we said, oh, we better make it work with these. It's the only thing that's going to work. I guess we got to figure this out.
And the
I'm gonna
budget was
say that narrows it
acceptable?
down.
And the budget, the budget was acceptable.
So if there's only one thing in the world that does it, that's probably not, well, I guess it is the cheapest, but it's also the most expensive.
Yeah. Yeah. It ended up, being affordable. Yeah.
Good.
Well, it's tricky, but it turns out that the same company that we used for the dome projectors, Christie, had something that we were interested in for this. So
Yeah.
it's the projection that's always the trickiest because it's the most expensive individual piece. And you need edge blending, and you need it to be automatable, and you need to be able to realign everything almost on a daily basis because of shifting material, as the building
room.
settles and such,
Yeah.
Does
Has to be-
temperature change that too?
Yeah.
Things expand and contract?
Oh, yeah.
Huh.
Yeah, there's one projector because of the way it had to be mounted, once again, flipped inverted, that warms up differently than the others. And that took us a few weeks to figure out why it was coming out of alignment when we would start the system up. And it's just because its mounting detail is different than the others.
Right,
That's crazy
gravity's
stuff like
affecting it
that.
differently.
Yeah. Oh, totally.
And you said that there was a series of projectors that you had at some point that needed, was it monthly new lamps? Or frequent new lamps? Are the new ones that you've got more forgiving than that?
Oh, no, these laser, RGB laser is amazing. I mean, when we first opened, it was 12-inch Barco CRTs. The biggest tubes ever made, biggest CR2T tubes ever manufactured for projection. They could barely make any light at all. But in the planetarium, that's okay.
It's
the
dark
resolution
in there.
was 1280 by 10, whatever the 4:3 resolution, those things were 5:4 that they could make, hooked to an Onyx, a 7-pipe Onyx reality monster. That's what we started with, to make the picture. And very quickly, we hired a guy whose single job was to go in the morning and realign it was 7 of these CRT projectors every day, to get it to look like something. And that got old quick. After about 6 months, we noticed that the reds and the blues were a lot less visible. And then by 18 months, you barely see them at all. So we had to do a full tube replacement every 18 months. And that got very expensive very quickly. And the best part was, in order to get them even to show that much light, you had to boost the voltage. You could stand behind those tubes, and if you put a piece of photo paper probably behind you, you'd probably get a nice X-ray. But I didn't spend out too much time hanging behind them.
Good. So you replaced those with Christie?
It was a long research project. So the first thing we did is we actually went to Rockwell Collins and used simulation projectors that they had made at that point. They had to be double stacked to get the brightness, and they were made with LCOS technology, which we found out very quickly burns out, and the dichroics die off. So we would double stack them, get them all aligned, everything would look beautiful, and then the colors wouldn't match after a few weeks. And we went on with this for a few cycles, and then our chief engineer, Jeff, who is now retired, started talking to Larry at Christie, the head of design, and they came up with this cockamamie scheme to build this projector, which is double modulated. And it took a long time, a very long time to get it developed. They gave us cinema projectors in the interim, which they had a very hard time blending because they weren't designed for that purpose. And then finally, along one day they come and say, all right, I think we got something. And that's when the eclipses became. Now they were also in talks with Dolby to do Dolby Vision, so it was kind of a tandem product to that,
Good.
similar in the construction, but the Dolby Vision had special sauce and special Dolby patented whatever
Dolby
codecs
sauce.
or whatever.
Hmm.
And also these don't have an IMB, so the cinema line has the IMB. These don't. These are just straight display port or HDMI input or SDI.
Hmm. That's pretty cool that Christie worked with you.
Yeah, well, it was a good selling point for them. They wanted to
Yeah.
get into that market.
Yep. Look what we built.
Yeah, and it was a good point for us because we wanted to get away from the gray. We wanted something that could do black level, and it does. It does stunningly. Like it's like a ridiculously wide contrast ratio, like 20 million to 1 or something. It's something ridiculous.
Amazing.
The main advantage to it is you can blend them digitally, so you don't need masking. And that's where it really shines, because you can put 6 of these things together and you can make one image, and you can't really tell where the seams are mostly. I mean, nothing's perfect, but
Mm-hmm.
hard to tell.
That sounds pretty good to me.
And with curves, there's no way you're going to use a video wall. Curving
Oh, no.
surfaces.
Mm-mm.
There's no way.
Well, there are people that do.
Really?
We went to go see Cosm, which is out in Utah. It's these guys that are making these sports venues, and they're making planetarium, solid LED planetariums. The big trick is, how do you get speakers to shoot through that?
Right.
They found a way, but it's even more complicated than what we're doing now. And a lot less air volume can get through because you got solid LEDs. So it's tricky. I think eventually it'll be the state of the art because they make no sound whatsoever, which is beautiful. But the problem is, I forget what they said. It was like 31 tons of material would have to be hung.
31 tons.
Something around there, yeah. Some ridiculous number.
You don't want something coming loose with that,
No.
That would be a bad thing.
And then the big problem is, how do you
Especially if you're
service if a
sitting under
panel
it.
goes out at the top? How are you going to get to it?
Yeah.
You got to bring a scissor lift in, and it's so there's a lot of complication. We're still talking about it because there are certain things about direct view that you can do that you can't do with projection.
Mm-hmm.
For one thing, it's a hell of a lot brighter, but there's some things you don't want to do either. So it's. I was just talking to Larry at Infocom. It's projection still seems like the answer for the near term, but I think eventually direct view will take over.
I was in New York in October and January last year and walked through the subway station down at the World Trade Center where you go underneath West Street. And they've got these screens on the wall that are, I don't know, 20 feet tall and 250 feet long or something, just absurdly big. And it's head level. So I'm 6 feet tall, so it's at 6 feet or 7 feet above the floor and going up. And it was astonishingly clear, even close up. When I looked over to the side, the pictures were great, I thought.
So it wasn't pixelated?
Well, I mean, it's individual LEDs, but it's not pixelated like
you would think it would be at that
yeah.
at that resolution. Yeah. Okay.
Yeah. It was amazing, but like you say, it's solid. And as you also said, it was quiet. It didn't make any noise at all that I could hear. I can't hear 12K anymore.
But if you're in a subway station too, I mean.
Well, this was a lobby. There was no subway train anywhere nearby.
Okay.
I mean, it was below you, but
I bet they emit RF.
The LEDs?
Some do like crazy, and others don't.
Yeah, well, I think was it JJ? He told us his
Yeah.
friend that does the stadium stuff. They have the
Yeah.
stadium displays that go all the way around the stadiums or basketball arenas, and his comment was they just made an enormous amount of noise. Maybe
Well,
it's
there's
all
the whole problem with pulse width modulation.
That being said, I've worked within 3 feet of those and not had problems with sound systems being affected. So some of them are a problem and others aren't.
Yeah, I think it's all in how you ground it and the power supply design and all that.
Yeah.
It can be done.
And
it gets more
shielding.
expensive. Yeah,
Shielding
it's
of
a
the
cost
parts
thing.
that radiate. Yeah.
There's companies that do it really cheaply and you
Yes.
pay for it with that stuff. But then there's
Yes.
guys who do it. And for the COSM guys, I'm pretty sure they have to be careful of that because the speakers are right behind the LED panels.
Mm-hmm.
Same thing with Sphere. I mean, Sphere, it's easier because the pixels are gigantic.
Right.
And they got big space for the hollow plots to go. But for what we would do in the Hayden, we would need a pixel dot pitch that would be much smaller. And we're still waiting for that to be
right
cheap enough to do it feasibly.
But the concavity of it seems like it's a problem.
It's really tricky. Essentially, they make panels of different shapes and they put it together like a jigsaw puzzle.
Right.
And
which is how all of those go together.
Yeah, it's not really spherical, but it's close enough at a certain distance.
Right.
You can get away with it.
The guy who was somehow a project manager or something of Sphere gave the keynote of the audio part of Sphere, gave the keynote address at the Audio for Virtual and Augmented Reality last summer here near Seattle. And I did the PA and AV for it and recorded and live streamed it. And you can see his talk on my YouTube channel, because that's where that goes when you live stream. And he was stuck with an hour and a half, and he said he had 20 hours of material that he could have given. But I thought he did a great job explaining how they developed those speakers and for that project and figured out how to do it and figured out all of the placements and the LED screen spacing to let sound come out and so forth. It was pretty.
It's amazing
project.
It's an amazing project, and what's funny is that even though they had all this advanced technology, they still, and it's the same problem we ran into. You still need to be able to produce a show, and the production tools are always very conservative. So you're running Pro Tools, you're running, you need to run time code, you need to run. So it becomes this battle between a doable production and a timeline versus, the off-the-wall experimental systems that these things usually get built on. So, and it was something that I didn't really touch on before earlier. It's like with Peter and the crew that we've used, they've all been doing these space shows with us for a long time. So they kind of know the limitations of the space and the realities of that. When you bring new people in, sometimes that can be good, but sometimes they can be off-put because there's things about it that aren't expected. It's like, what do you mean I only have 6 weeks? Or what do you mean I can't put that sound there? So that's where it becomes helpful.
It seems immensely valuable that you've got a consistent group of people there who are super familiar with the space, the gear, and the desired result. That's really cool.
Yeah.
Yeah, I can't think of doing it any other way. I mean, it
I
would
can
just,
think of lots of ways you could do it, but it would
well, it would not,
the
I mean,
result would not be as consistent or
it would be
pleasing.
more problematic to do it in another way.
You would think
It,
so.
you would
Right.
need the consistency of the people who are familiar with what you have,
Right.
because what you have is so unique. It's not like it's out of the box or anything that somebody
No.
else is going to know exactly what it is, you know?
Yeah, and that's what got really tricky when we talked to all the speaker manufacturers. It's like, well, Acoustics has their own spatialization system, but could we get the mixer to buy into it if it's
Yeah.
not something he's familiar with?
Hmm.
Holoplot has their own unique way of doing it, but does that make sense for the production timeline? So all these issues get complicated into that, and it really makes it difficult to try to go in a different direction. Because you're like, well, we know how Meyer's stuff works. We've done it for 20 years,
Yeah. Yeah.
um, but
I
there's a
wanted
lot.
I wanted to say for the record how cool it was to me personally that you guys are using Meyer stuff, which I didn't find out until a couple of weeks ago, I think, long after we decided to do this. I've been a Meyer guy, small-time Meyer guy since 1981. And like I said, I got some X40s and X20s 6 months ago now, and have been using them to some extent on the shows that they were the right thing for. And the X40s are just amazingly consistent. And I was using UPJs before that, which are 80 degree. And that extra 30, and might even be 40 degrees, is really astonishing how.
The marketing department says an extra 40.
Yeah, that's what I think. I think they're labeled as 120, and I believe it. I believe it. I'm not as critical as Bob is. Bob is really, going for it and rigorous. But it's I always had to put front fills in at this one place that I do a bunch of shows, and with these I don't need front fills at all. And it's not a hugely wide space, but I needed front fills with the 80 degree. I could either point to the middle or I could point to the sides. And I pointed to the sides because I can cover the middle shortly. It's tougher to cover the sides all the way to the back. But they're really awesome speakers.
They are nice. They are really
and
nice.
John and Helen are such cool people. And John is just an amazing person to talk to. And I get new wrinkles in my brain every time I've ever talked to him to absorb what he's saying.
I took them on a tour,
Uh-huh.
and they ended up in the astrophysics wing, and they were talking to Jackie Faraday, who's the curator for the new show.
Cool.
And they went off on some tangent about 3D modeling of underwater.
Yep.
There was some project he was doing for the Navy, and I was just like,
that
what
John was doing for the Navy?
Yeah, it was something, and it was like
awesome
holographic imagery under the ocean with speakers, and I was just like, all right, now I'm a little lost here.
Yep.
But,
and he's into all kinds of stuff like that, and it's amazing. It's remarkable and amazing. So
then I took them to the butterflies, and they were like, "Oh, we go down to Costa Rica or something." They go. He goes to photograph the butterflies like in situ, and I was like, "Well, that's got to be a fun tour."
They are amazing people,
and lovely, and just so down to earth,
sweet, very sweet people. For what the level that they operate on, for them to be so sweet and such wide-ranging interests, it's amazing. It's cool. It's really, really, really cool. Should we stop it on that note?
Yeah. I got to break off, but I appreciate you all letting me ramble. And Luke, an excellent presentation as always. I really enjoyed it.
Oh,
likewise.
Our hats are off to both of you.
Yeah.
Thank you so much. we'll look forward to seeing you another time. I hope.
Yeah, you guys are always welcome, and we'll definitely chat again.
Yeah.
Isn't Luke on the committee now?
Yeah.
Luke is on the committee. We will be talking with him
Ooh,
more than he wants, I'm sure.
Give him all the dirty jobs now.
Yeah, the new guy.
Muck out the stalls.
Yeah, we told you about the restroom duty, right?
Yep.